A very warm good morning to everyone. I hope all the participants have joined. Still, the number is less, so I think they are in the process of joining. So, our speaker of today's morning have already joined.
I think screen is visible.
Yes, sir, it's fully visible. You just need to press F5 so that it gets turned into that full slide mode, right? So, sir, we will wait for 7 6 7 minutes, and then we'll start the lecture. Hmm? I think we can start. Sir, can you hear me? Professor Agnihotri, am I audible to you?
Hello.
Yes, sir. Good morning. Can you hear me?
Yes, yes.
I think we can start then, right? Because it's already 4 minutes late. So
Okay.
I think 78 participants have already joined. We have around 120 participants, but I think they are in the process of joining. So we can start the lecture.
Okay.
Warm good morning to all the participants and our speaker of the day, Professor Agnihotri, to the third day of faculty development program on disaster resilient infrastructure. Today we have with us Professor Arvind Kumar Agnihotri. He is the professor in the Department of Civil Engineering, NIT Jalandhar. He has done his PhD in the field of civil engineering from IIT Roorkee, master's from NIT Kurukshetra, and bachelor's from Punjab University. So I welcome you, sir, and thank you once again for giving us this opportunity to host you online for this faculty development program. And sir is also, in many ways, directly or indirectly part of activities that Himachal Pradesh University conducts. He's also in the board of studies of the our BTech course. So, sir, I again welcome you on behalf of it, on behalf of my organizing committee. And sir has published large number of papers. So he's a senior professor in the field of liquefaction, geoenvironmental engineering, ground improvements, reinforced earth, and recycled materials. So that's the area of research that he's presently taking up. He has also guided around 12 PhD students, and many are presently doing their PhD under his supervision. He's also having many administrative and other responsibilities with him because being the senior professor at NIT Jalandhar. Uh, he also was the founder chairman for Indian Geotechnical Society Jalandhar chapter. He has received many awards. Some of them are Best Teachers Award, and then yeah. So I think these are some of the awards that he has received. So, sir, with these words, I would like to welcome you again uh, for accepting our invitation. And with these words, over to Professor Agnihotri. Thank you, sir.
Thank you, Dr. Mahesh, for introducing me with nice words. So today's lecture is on liquefaction. So before I start with liquefaction, I would like to give some idea about the samples which should be collected, which should be tested for liquefaction potential, which soil should be tested. So I'll give you some idea, recall your memories for soil exploration, up to what depth soil exploration should be carried out, up to what depth we should collect the samples for checking the liquefaction potential. So I will give you a brief idea about general soil exploration requirements first before I start actual liquefaction. So depth of exploration, as all of you must be knowing, that should go up to the significant depth below the base of the foundation. Significant depth generally we take where the vertical stress becomes 20% of the load intensity. So up to significant depth, soil exploration should be carried. Samples should be collected from the field within the significant depth, at least up to depth where vertical stress becomes 20% of the load intensity. If we see, if area is square loaded area, if you see the pressure bulbs, so 20% load intensity, if you see pressure bulb where set in 0.2, that is 20% stress level. So that is approximately at 1.5 B. So minimum depth of exploration should be 1.5 B, and for important structures we should go up to 2 B, where stresses become almost 10% of the load intensity. This is for square loaded area. Similarly, for circular loaded area, also approximately 1.5 bits, though it's a little bit lesser than that. So 1.5 B should be the minimum depth for soil explorations. For circular loaded area also. Now, if the loaded area is strip-like, suppose continuous footing under the column, under number of columns, continuous footing is there, that is strip load. So in case of strip load, you see 20% load intensity, 0.2 Q is at 3B. Here it's written 6 times small b. Small b is half of the foundation size. So full is capital B, that is 3B. So minimum depth of exploration for continuous footing case, for strip footing, should be 3B, where stresses become 20%, and 10% at 6B. You see 10% stresses are at 6B. So depth of exploration, that depends on shape of the loaded area. If it is square or circular, then up to 1.5 to 2B is sufficient for collecting the samples. When it is strip type loading, then we should go from 3B to 6B for collection of samples. Now, when foundations, they are isolated. When we call the foundation as isolated, isolated means spacing between the foundations is more than 4B, where B is the width of the foundation. If it is more than 4B, then only they are isolated. Otherwise, there will be some interference. When foundations, they are closely spaced, their pressure valves, they will interpenetrate. So overloading or overstressing of the soil will take place. So if you see figure A, in figure A, foundations, they are isolated. So in that case, 1.5B below the base of the foundation is sufficient. But in figure C, if you see, foundations, they are closely spaced. Their stress zones, they are interpenetrating. So soil will be overstressed in that case. So when such condition is there, when foundations, they are close, particularly when spacing becomes almost 1B, then we should go for soil explorations up to 1.5 times the combined width of all such isolated footings. As shown in this figure C, you see B is the width, combined width, not the small width of isolated footing. It is combined width. Similar to raft, if you see figure B, in case of raft is combined footing under all the columns. When chances of differential settlement are there, when soil is very weak, in that case we use a raft foundation. Then explorations should be carried out up to 1.5B, where B is the width of the raft. Similar to the previous case where C I have discussed, and foundations, they are closely spaced. When foundations are closely spaced, and if the area covered by the foundations, isolated footings, exceeds 50% of total area, then it is recommended that we should go for raft, because then raft will become economical. So B is the width of raft, or B is the width of combined width of all isolated footings, whatever the case may be. It should not be small b of individual footing. Similarly, for piles, where we use piles, then below 2/3 of the length of the pile, soil exploration should be carried out up to 1.5 times the combined width of piles, combined spacing between outer piles. So 1.5B. So this is very important, that up to what depth soil should be explored, soil should be investigated. Only then your liquefaction studies will be useful. If you are collecting samples from only top 1 or 2 meters, then you are saying that we have done liquefaction studies also. They will not be effective. So depth of exploration is very important. Similarly, if we have rectangular footings and length of the footing is greater than width in rectangular footing, if they are isolated, as I have told earlier, if they are isolated, spacing between the rectangular footings is more than 4B, then we can go up to 1.5B. And otherwise, if spacing is lesser than that, then 1.5 times the length of rectangular footing should be depth of exploration. Similarly, when footings are closely spaced, then if spacing is more than 4B, then they are isolated only, then depth should be 1.5B. And if spacing between the footings is between 2B to 4B, then we should go up to 3 times the width of isolated footing. And if spacing is lesser than 2B, Then further depth of exploration should be increased to 4.5 B. So these guidelines should be followed while collecting the samples. Similarly, for highway embankments, we go up to 2 to 3 meters. For earth dams, soil exploration should be carried out up to W by 2, where W is the base width of the dam. W by 2 or hard strata, whichever is earlier. So up to hard strata or W by 2, that should be depth of exploration. Similarly, in concrete dam, depth of exploration should be 1.5 to 2 times the height of the dam. So D, 1.5 to 2 times the height of the dam. And in case of retaining walls, if retaining wall is on good strata, then 0.75 to 1 times the height of the retaining wall. If it is on compressible soil, then 2 times the height of the retaining wall should be the depth of exploration. Am I audible? Hello? Am I audible?
Yes, sir, you are absolutely audible, sir. Continue.
Okay. And depth of exploration for tunnels, if D is the width of tunnel, base width of tunnel, then depth of exploration should be equal to the base width. Similarly, number of boreholes and spacing between boreholes, that is also important. For high-rise buildings, guidelines are if soil is uniform, 45 meter center to center, for every soil 30 meters center to center, for every soil 15 meters center to center, and minimum 5 boreholes should be there. Minimum 5 boreholes for high-rise buildings, and for single or double-story buildings, minimum 3 number of borings should be made up to the significant depth as I explained. For bridge apartments, 1 to 2 boreholes for each foundation unit, and for highways, it is 300.
Sorry to interrupt, Professor Agnihotri.
Yes.
I think we are having some interruptions in between because of some.
Huh?
There's some noise. It's getting break. So what we can do, Professor, what you can do, you can switch off your video so that connectivity remains consistent.
Okay.
Yeah. Thank you, sir. Yes, sir. Please go ahead. Yeah.
Okay. Now let's start with liquefaction. So up to this, I have given you some idea about depth of exploration, of which soil should be explored, from where samples should be collected, when we have to test them, even for checking the liquefaction potential, which soil should be tested. Now, liquefaction has been a major cause of damage to soil structures, lifeline structures, building foundations during past earthquakes. It clearly possesses clearly poses a significant threat to the integrity of structures and other facilities during future earthquakes. Evidence of occurrence of liquefaction has been reported from large number of earthquakes, as shown here. Shunai in 1894, Assam, Kanto, Bihar. So at so many places it has been noticed that liquefaction has taken place. But it was only after earthquakes at Negata and Alaska in 1964 that problem of soil liquefaction was investigated in greater detail, and efforts have been increasingly directed towards the development of methods for evaluating the liquefaction potential. Soil liquefaction
Okay.
describes the behavior of soils that, when loaded suddenly, they suffer a transition from solid state to a liquefied state, having the consistency of heavy liquid. Liquefaction actually more likely to occur in loose to moderately saturated granular soils with poor drainage. This is important. In loose to moderately saturated granular soils with poor drainage, such as silty sands, and pebbles capped or containing seams of environmental sediments. So wherever you get soil like sand in loose condition or silty sand, and water table is likely to be high, in that case chances of liquefaction increase. During loading, usually cyclic undrained loading, earthquake loading loose sand tend to decrease in volume, which produces an
Sir, can you hear me?
yes.
I think because of some internet connectivity issue on your, I think on your side, could you please switch off your video so that we can hear you properly?
नहीं, I switched off. अच्छा फिर हो गया on.
Yeah, because I think, now it is off, please, sir. Please go ahead, because I think your voice is breaking in between sometimes.
Okay.
So, yeah, thank you very much.
During loading, usually cyclic undrained loading like earthquake loading, loose sands tend to decrease the volume. This produces an increase in the pore water pressures. So whenever there is decrease in pore water pressure, consequently there will be decrease in shear strength. So there will be reduction in effective stress. If mathematically we see theory liquefaction, strength of sand, that is due to internal friction only. So S equal to, equation S equal to C plus sigma tan phi, for sand it will become sigma tan phi. So sigma effective sigma n minus U pore water pressure. So normal pressure minus pore water pressure. So U is gamma W into Z. So sigma and gamma saturated into Z, shear strength therefore becomes gamma submerged into Z into tan phi. Now, if there is an increase in pore water pressure, say from U, there is increase in pore water pressure, it becomes U plus delta U. Delta U is, let us say, gamma W into SW dash due to shaking of the ground due to earthquake. So strength then will become gamma submerged into Z minus for increase in pore water pressure. So gamma submerged Z minus delta U into tan phi. So it will become gamma submerged Z minus delta U is gamma W SW dash into tan phi. Now it's seen that with the development of additional positive pore water pressure, the strength of sand is reduced. So for complete loss of strength, gamma submerged into Z is equal to gamma W into HW dash. So when gamma submerged into Z is equal to gamma W into HW dash, there will be complete loss of strength. So HW dash upon Z therefore becomes gamma submerged over gamma W. Gamma submerged from basic principles equation, you know, G minus 1 over 1 plus E into gamma W is equation for gamma submerged in terms of G and E. So that will give you HW dash upon Z equal to G minus 1 over 1 plus E, which we call as critical hydraulic gradient. So ICR. So HW dash upon Z is G minus 1 over 1 plus E. So if the void ratio of the soil is close to 0.6, if E is 0.6 in this equation, if E is 0.6, G normally for soil is 2.6%. So 2.6 minus 1 divided by 1 plus 0.6. So that will give you 1. Critical hydraulic gradient will become equal to 1. So the equation HW dash upon Z equal to G minus 1 over 1 plus C, that will be equal to 1. That means when HW dash becomes equal to Z, then there will be complete loss of strength to occur. An additional water height when equal to depth of deposit. When additional water head is equal to depth of deposit, then there will be complete loss of strength. Liquefaction will occur. Soil will liquefy. It will behave just like liquid. Now, let's talk about effects of liquefaction. Liquefaction can cause damage to structures in several ways. Buildings whose foundations bear directly on sand, which liquefies, will experience a sudden loss of support, which will result in drastic and irregular settlement of the building. When liquefaction will take place, when sand below the foundation, when foundation soil starts flowing, when it loses its shear strength. So building whose foundations bear directly on sand which liquefies, that will experience a sudden loss of support, which will result in drastic and irregular settlement of the building. Liquefaction causes irregular settlements in area liquefied, which can damage buildings and break underground utility lines where differential settlements are large. Pipelines and ducts may float up through the liquefied sand. So these are effects. Further, sand boils can erupt into buildings through utility openings, may allow water to damage the structure or electrical systems. Soil liquefaction can also cause slope failures. Areas of land reclamation, they are often prone to liquefaction because many are reclaimed with hydraulic fill. They are often underlain by soft soils, which can amplify earthquake shaking. Soil liquefaction was a major factor in the destruction of San Francisco's Marina district during 1989 Loma Prieta earthquake. Mitigating potential damage from liquefaction is part of the field of geotechnical engineering. Further, there will be loss of bearing capacity. When the soil supporting a building or other structures liquefies and loses strength, large soil deformations can occur, allowing the structure to settle and tip. During the Niigata, Japan earthquake of 1964, spectacular bearing failures occurred at the Kawajiku apartment complex, where several four-story buildings tipped as much as 60 degrees. Apparently, liquefaction first developed in a sand layer several meters below ground, then propagated upward through overlying sand layers. The rising wave of liquefaction weakened the soil, supporting the buildings, and allowed the structures slowly to settle and tip. Most of the buildings were later repositioned upright, underpinned with piles, and reused. So I mean to say that liquefaction is very, very important. People think that if building is properly designed, so then it will not be having any problem during earthquake. But these buildings, in these buildings, in these apartments, there was no structural damage. Buildings, they toppled due to liquefaction because foundation soil that moved away. So buildings toppled, then they were later repositioned upright because there was no structural failure. They were underpinned with piles and reused. So that's why liquefaction studies are very essential. Flow liquefaction is a phenomenon in which static equilibrium is destroyed by static or dynamic loads in a soil deposit with low residual strength. Residual strength is strength of liquefied soil. Because liquefied soil has low strength. Static loading, for example, can be applied by new buildings on a slope that exert additional forces on the soil beneath the foundations. Earthquakes, blasting, pile driving, they are all examples of dynamic loads that could trigger flow liquefaction. Once triggered, the strength of the soil susceptible to flow liquefaction is no longer sufficient to withstand the static stresses that were acting on the soil before the disturbance. You see how buildings toppled during 1964 Niigata earthquake. This picture shows that there was no structural damage. Buildings toppled, then they were again raised and reused. You can see what I have told you, effects of liquefaction. Due to liquefaction, buildings toppled. There was no structural damage to the buildings, they were properly designed. Similarly, liquefaction allowed the seaward to float upward. And liquefied soil also exerts higher pressure on retaining walls, which can cause them to tilt or slide. Movement can cause settlement of the retained soil and destruction of structures on the ground surface. Similarly, increased water pressure, they can also trigger landslides, cause the collapse of dams. One collapse is shown here in San Fernando earthquake 1971. Here you see in this picture how liquefaction takes place. This appears on the ground just like fountain. When under pressure, sand moves, that will come out as fountain. It will erupt like this as shown here. So this shows that liquefaction has taken place. So if such site you see, that will give you idea that liquefaction of soil has taken place. Which factors affect the liquefaction? Now we will talk about some factors affecting liquefaction. Soil type, as I told you earlier, soil loose sand in saturated condition that is susceptible to liquefaction. For cohesionless soil, soil type is most easily characterized by grain size distribution. There is some evidence to show that uniformly graded materials are more susceptible to liquefaction than well-graded materials. Well-graded materials, they behave better than uniformly graded materials, and that for uniformly graded soils, fine sands tend to liquefy more easily than coarse sand, gravels, silts or clays. So most susceptible to liquefaction are fine sands, uniformly graded soils, and in that fine sands, they tend to liquefy more easily. In a study of bridge foundation displacements in Alaska earthquake, Ross et al. Reported that there were no cases of bridge damage due to this cause for structures supported on gravels, but there were many cases of damage of bridges supported on sands. So similar bridges which were supported on gravels, there was no problem. Which was supported on sands, damage took place. Kishidi reported that liquefaction occurred at a site where the upper 15 feet consisted of medium sand, but there was no liquefaction at an adjacent site where the soil in this depth range was sandy silt. These are actual examples, actual observations from the field after liquefaction has taken place due to earthquake. So these field observations, they are supported by results of laboratory cyclic load tests on a wide range of materials. Then after getting these observations, then they were supported by lab cyclic load tests also. It has been generally recognized that susceptibility of a given soil to liquefaction will be determined to a high degree by its void ratio or relative density. This you know that void ratio or relative density, that tells us about the state of the soil. So in any given earthquake, loose sands may liquefy, but the same materials in denser condition may not. Materials are same, but if they are in dense state, they will not liquefy. When if they are in loose state, they will liquefy. In the Niigata earthquake, Osaki reported that liquefaction was extensive where relative density of sand was about 50%. For same sand where it was having relative density of more than 70%, no liquefaction was observed. Further, lab tests that of all types show important influence on this factor. So relative density, void ratio, that is also important factor. Similarly, initial confining pressure. There is considerable evidence to show that under earthquake loading conditions, in contrast to flow slide susceptibility under static loading conditions, the liquefaction potential of soil is reduced by an increase in confining pressure. Laboratory tests by numerous investigators, they have shown that for a given initial density, stress required to initiate liquefaction under cyclic load conditions increase with initial confining pressure. Effect was also shown in the field during Niigata earthquake, where soil under a 9 feet fill remained stable, but similar soil surrounding the fill liquefied extensively. Seed and Idris, they have done so much work on this. They have studied this. Further, intensity of ground shaking, that is also important for a soil in a given condition and under given confining pressure. The factors which we talked about earlier, for same factors, the vulnerability to liquefaction during an earthquake depends on magnitude of the stresses and strains. Thus, they are related to the intensity of ground shaking. Significance of the applied stresses has been shown by many laboratory investigations also. The important fact of ground shaking intensity in the field is very well illustrated by the soil behavior at Niigata in Japan. The relatively loose sands in Niigata have been shaken by 25 earthquakes in past 370 years. Relatively loose sands in Niigata have been shaken by 25 earthquakes in past 370 years. Historical records show only 3 occasions in which liquefaction has been reported. Same soil, same everything. In past 370 years, there were 25 earthquakes, but only at 3 occasions liquefaction taken place. On these occasions, the estimated ground accelerations were in excess of 0.13 G. So when ground accelerations were less than 0.13 G, there was no liquefaction observed on the same sites. So this is how the intensity of ground motion is important for evaluating the soil liquefaction potential. Similarly, duration of ground shaking. Duration of ground shaking is also important. If duration is small, duration of ground shaking is important in determining general way the number of significant stresses or strains to which soil is subjected. All laboratory studies of soil liquefaction under cyclic loading conditions show that for any given stress or strain level, the onset of liquefaction depends on the application of requisite number of stress or strain cycles. In the field, the importance of this is perhaps best illustrated by the landslides which were triggered by liquefaction in Anchorage during Alaska earthquake of 1964. These slides did not occur until about 90 seconds after the earthquake motion started, indicating the need for development of significant number of stress cycles to induce liquefaction. Clearly, if the duration of ground shaking had been only 45 seconds, no liquefaction or soil instability would have developed. So, duration of ground shaking is also important to trigger liquefaction. Then location of drainage and dimensions of deposit, they are also important. Sands are generally more pervious than fine grained soils. However, if previous deposit had large dimensions, the drainage path increases. If deposit is large, then drainage path increases. Under quick loading conditions during an earthquake, deposit may behave as if it were undrained, even if it is having permeability, but it behaves as undrained because of its length, dimensions. Therefore, the chances of liquefaction are increased in such a deposit. The introduction of gravel drains to stabilize the potentially liquefiable sand deposit has been proposed by Yoshini and Kubabura in 1971. They have introduced gravel drains. Seed and Booker and Seed, they have proposed an analytical procedure for designing such drains. Drainage system should be properly designed and gravel drains should be provided. They have said that drains are considered effective only if the drain material is about 200 times more permeable than the soil in which they are installed. Only then it will be effective. If the drain material is 200 times more permeable than the soil. So drainage path is reduced by introduction of these gravel drains. So drainage path should not be very large. It should be reduced by providing gravel drains. Further factors are methods of soil formation, investigations carried out by and other, they have demonstrated that liquefaction characteristics of saturated sands under cyclic loading conditions, they are significantly influenced by the method of sample preparation and soil structure. Similarly, period under sustained load, that is also important. If period is more, then liquefaction takes place. If period is not that much, so sometimes liquefaction may not take place. Similarly, it depends on previous strain history also. If you are stressing it time and again, the same soil, so its chances of liquefaction will increase. Entrapped air, if we see, if air is entrapped in water in which pore pressure develop, part of it is dissipated in compression of entrapped air. So entrapped air helps in reducing the possibility of liquefaction because some energy will be gone in pressing the entrapped air. So pore water pressure developed will be smaller. So liquefaction chances will be reduced if entrapped air is there. Now you see the limits in the gradation of soil. 4 curves are shown here on this grain size distribution graph. If your soil lies between these, then chances of liquefaction are there. If they lie between the middle two curves, boundaries for most liquefiable soil, you see boundaries for most liquefiable soil, they are in sand, mostly fine sand, that boundaries for most liquefiable soil. Then outer boundaries, they are for potentially liquefiable soil. If your soil is outside these boundaries, if your gradation, if your sieve analysis gives the soil which is outside these boundaries marked here, then liquefaction may not take place in that area. Actions to mitigate liquefaction. There are 4 general classes of mitigation measures available to geotechnical engineer to ensure the desired functionality and safety of engineered projects subject to liquefaction. These are changing operational procedures for the project. These are non-structural solutions, changing operational procedures. Owner of the project, he will take the decision. Then in situ improvement, geotechnical engineer can suggest changes to project structure. Some structural solutions may be given. I'll talk about these, what type of structural solutions can be given. Then control of undesirable pore water pressures. There are drainage solutions, as I told you. Drains should be provided, gravel drains should be provided, or stone columns. They are also helpful. They behave just like drainage path. So changing operational procedures, these are decision options available to the owner or responsible operator of a project. After the likelihood of liquefaction failures and their consequences have been identified, after investigating the soil, it has been reported to the owner that there are chances of liquefaction. Then owner of the project, he may decide that he will not take any action. He will say, if earthquake comes, then it will be people's luck who will stay there. So he may decide to take no action, or control or relocate or warn potentially affected parties to reduce loss of life or property. He can relocate the project, or he can give warning to the parties that if liquefaction takes place due to earthquake, that is your responsibility, your risk. He can So just like this, abandon the proposed or existing project. He can abandon the project. He can say that he will not construct the building there. Although the most feasible operational option must be determined on a case-by-case basis. Examples of second option could include restricting access to potential hazard areas, early warning systems established through local law enforcement officials, lowering of reservoirs to reduce inundation areas. So such type of actions, these are operational procedures. Then methods for improving in situ foundation conditions. Methods for improving in situ foundation conditions to reduce liquefaction. There are removal and replacement of unsatisfactory material. One action may be taken like this: removal and replacement of unsatisfactory material which is liquefiable, or densification and increase of lateral in situ stress, or in situ improvement by alteration of material, or grouting or chemical stabilization. So these are some methods for improving in situ foundation conditions if there are chances of liquefaction established from soil exploration studies. Removal and replacement of unsuitable material may be accomplished by excavation and engineered compaction of the existing soil, excavation and engineered compaction of materials improved with additives, excavation of existing soils and replacement with properly compacted non-liquefiable soils, densification of in situ materials. There are densification techniques like compaction piles, vibratory probes, vibroflotation, compaction grouting, dynamic compaction. These are densification techniques which can be adopted to densify the soil so that it will not be in loose state and susceptible to liquefaction. Vibroflotation is very popular for densification. Vibroflotation, then dynamic compaction, stone columns, compaction piles. These are solutions given by geotechnical engineers if area is found liquefiable. Compaction grouting, then drainage techniques. As I told you, gravel drains, they are provided so that length of path is reduced so that pore water pressures can be dissipated. Improved or altered in situ material, mixing in place material with additives, removing in place material by jetting and replacement with suitable material, grouting operations. There are some structural solutions also, like we can provide a berm. A berm may be added to the downstream slope of an embankment, okay, to make it stable, to make it more stable. Another berm can be added. Stable embankment may be similarly used to retain potentially liquefiable soils and prevent their flow or lateral spreading. Similarly, dams freeboard can be increased to accommodate slumping yet retain a full reservoir. So these are some structural solutions. Berm can be added to the downstream slope. Stable embankment may be used to retain potentially liquefiable soil, prevent the flow. Dam freeboard can be increased. These are some structural solutions. The questionable foundation support offered by liquefiable soils may be corrected by the use of end-bearing piles, caissons, fully compensated mat foundations. So proper foundations which are recommended for such liquefiable areas should be recommended. Then drainage solutions, they are relief wells, dewatering systems, air injection into bore water, drains, control of pore pressures by pressure relief wells. These are some drainage solutions. Active dewatering, air injection. Normally air injection is not done, but this method is there. Now we will talk about evaluation of liquefaction potential. So up to this, I have given you idea about up to what depth soil exploration should be carried out, from where samples should be collected. Then liquefaction chances are there in loose sands under saturated conditions. Then gradation I have shown that within that zone, if soil lies, then chances of liquefaction are there. So if you, after establishing that liquefaction chances are there, then different structural solutions, different geotechnical engineers advices, densification techniques, drainage solutions, operational procedures, that I have told you, that how we can take care of liquefaction if it is taking place. Now, how to evaluate liquefaction potential? For evaluating the liquefaction potential, first method is SPT. This is very popular method for calculating the liquefaction potential. Standard penetration test is performed at the site. I hope most of you are civil engineers, so must be knowing about this standard penetration test. Borehole is made at the site and number of blows of 65 kg hammer falling freely through a free fall of 75 centimeter or 750 mm. They are given for penetration of standard split spoon sampler into the ground. For 300 mm penetration, number of blows are recorded. Number of blows which are recorded for 300 mm penetration, they are called N value. So SPT is performed at the site, starting from ground level up to the significant depth, as I told you. Minimum up to significant depth. Standard penetration test is performed at different intervals. Let us suppose first test you perform at 1 meters, then next at 2 meters, 3 meters. Minimum vertical interval is 0.75 meter. It should be, we can go up to 1.5 meters this interval. It can be changed depending upon variation in the soil, but in no case should be, interval should be more than 1.5 meters. So SPT is performed at the site. After performing SPT, number of blows for 300 mm penetration of standard split spoon sampler, they are recorded. That is our N value. Now for analysis, a corrected N value denoted as N160. That N value here has been designated as N160 because it is assumed that efficiency is 60% only. Whatever energy we are applying, 60% is actually applied, others are losses. So we call it N160. N value recorded is designated as N160. N160 is equal to Nm. Nm, they are observed or measured values at the site for 300 mm penetration multiplied by some correction factors. Those observed N values, they are corrected for corrections. For overburden correction, Cn, correction factor for hammer energy, this is not hammer, this is hammer energy. Then Cb is correction factor for borehole diameter, Cr is correction factor for rod length, Cs correction factor for samplers with or without liner, Cn effective vertical overburden pressure at the depth of SPT. So SPT you have performed at different depths. So accordingly, these corrections are applied to the recorded, to the measured or observed values. Then after multiplying the observed values with these correction factors CN, CE, CB, CR, CS, you get N160 value. So first step is perform SPT, then get NM values, measured N values from the field. Now correct those for different corrections, you get N160. Now you have N160 with you. This I told you that normalized N value is for 60%. So that's why we call it 60 N160. With respect to energy ratio, it is believed that approximate average SPT energy for North American practice is 60%. That's why we call it N160. Now, after calculating N1, uh, for calculation of N160, CN, overburden correction. Overburden correction will be calculated using this equation. Cn equal to Pa over sigma V0 dash raised to power 0.5. Pa is atmospheric pressure, that is 100 kPa. Sigma V0 dash effective overburden pressure at depth of SPT. Suppose you have performed tests at 1 meter. So gamma into Z. Gamma will be gamma effective. If water table is there, then below the water table gamma will be taken as gamma submerged. So effective overburden pressure will be calculated. Gamma into Z. Z is 1 if you are performing test at 1 meter. At 2 meters, gamma into 2. So if gamma is changing, gamma 1 Z1 plus gamma 2 Z2 and so on like this, you will calculate effective overburden pressure sigma V0 dash. Then calculate Cn, Pa over sigma V0 dash whole raised to power 0.5. That will give you overburden correction Cn. Other corrections, they are taken from this table. For borehole diameter, if borehole dia is between 65 to 115 mm, then CB is 1. For 150 mm, 1.05. For 200 mm, 1.15, like this. Tables are there for other corrections. So other corrections, they are applied using this table. Overburden correction you have calculated. So now you have N160 value with you. N160 is observed value multiplied by various correction factors, overburden correction and other corrections. Overburden correction formula I have told you. Then other corrections tables are there. From that table you can take other correction factors, substituting the values. You can calculate N160. Now, after calculating N160, you will convert it to N160 for clean sand. N160 will be converted to N160 CS. CS means clean sand. Converting N160 to N160 CS, this formula is used. N160 CS equal to alpha plus beta into N160. Seed and Idris have developed these equations. Seed and Idris, they have done a lot of work on liquefaction. N160 CS is calculated using this equation. N160 CS equal to alpha plus beta into N160, which you have calculated from first step. Alpha here is exponential 1.76 minus 190 over Fc square. Fc is fines content. Fines content means in the sieve analysis, the material passing 75 micron sieve is fines content. If 20% is passing 75 micron sieve, then Fc will be 20. If 30% is passing through 75 micron sieve, then Fc is 30. So substitute the value in this equation. Alpha and beta, they are calculated. Substituting the values of alpha and beta in the equation, N160 CS can be calculated. So you are to calculate N160 CS for clean sand. First step is perform test. After performing test, you will get NM. Then from NM, you will calculate N160 after multiplying it with the correction factors. Then N160 is converted to N160 CS. Now you have N160 CS value. You will calculate CSR value using this equation. CSR, cyclic stress ratio. Cyclic stress ratio will be calculated as 0.65 sigma V0 A max over sigma V0 dash RD. A max is maximum horizontal acceleration at the ground surface. As when I was explaining you, when earthquake was of acceleration 0.13 g, there was liquefaction noticed. When it was lower than that, it was not observed liquefaction at the site. So what horizontal acceleration you are expecting in that area where you are going to construct a structure? So accordingly, A maximum value you will have. So A maximum will be in terms of G, 0.1 G, 0.2 G, 0.115 G, like that. Sigma V0 and sigma V0 dash you will calculate effective overburden pressure sigma V0 dash, and sigma V0 is total. Total means when water table is there, then you will take gamma saturated into Z. Below the water table, you will take gamma saturated into Z. For effective overburden, you will take gamma submerged into Z. So calculate overburden pressure, total overburden pressure and effective overburden pressure. So for that borehole, now you have soil, different gamma values at different depth. So you can calculate CSR. RD is there. RD is reduction factor. RD you can calculate from the given curves or from equation. Let me show you this. RD you can calculate from these equations. RD equal to 1 minus 0.00765 Z for Z less than 9.125 meter, 1.174 minus 0.0267 Z for Z between 9 to 23. So these equations can be used for RD value. So substituting all the values in the equation, you can calculate CSR. So from this CSR equal to 0.65, sigma V0 is overburden pressure, total sigma V0 dash is effective overburden pressure, A max is acceleration, maximum horizontal acceleration expected at the site, RD reduction factor, I have shown you the equations. So substituting the values in this, you can calculate CSR. Now you have CSR with you. Further, this CSR value should be converted to CSR value for an earthquake of magnitude 7.5, because the curves which are available given by SEED and IDIS, they are for 7.5 magnitude earthquake. So whatever value of CSR you got from the equation 0.65 sigma V0 A max over sigma V0 dash into RD, that should be divided by magnitude scale factor. Magnitude scale factors, they are given in the form of table. I'll show you. So value which you calculate from the equation, that will be divided by magnitude scale factor to convert your CSR value to an earthquake of magnitude 7.5. These are magnitude scale factors. You can use these curves also. From this curve, you can take magnitude scale factor or these tables. Suppose expected earthquake magnitude in your area is 6.75. So magnitude scale factor is 1.13. So whatever CSR value you have calculated from the equation, that will be divided by 1.13 to convert your magnitude to earthquake of magnitude 7.5. Your CSR value now will be whatever value of CSR you calculated divided by this magnitude scale factor. That will convert your value to 7.5 magnitude earthquake. Now this you have used RD. RD can be taken from these curves also or equations also. These equations are for RD. Now you have calculated CSR for an earthquake of magnitude 7.5. You will also calculate the value of CSR from these curves. These curves are given by seed and address. From these curves, this solid line, which is for FC less than equal to 5%, this solid line curve will be used. Modified standard penetration N160, you have calculated N160 CS, you will use that value. N160 CS corresponding to N160 CS, you see the value of CSR from this solid line curve, because this solid line is for clean sand. When FC is less than equal to 5%, we call it clean sand. So from this solid curve corresponding to N160 CS, you see the value of CSR from this curve. So this value which you get from the curve, that is resistance ratio. One CSR you have calculated from the equation. After calculating it, you have divided it with magnitude scale factor so that it becomes comparable to the value which you get from this, because this curve is for M equal to 7.5 earthquake. After seed ATAL, this is for M 7.5 earthquake. That's why the value which we have calculated earlier, we have converted that value to 7.5 earthquake so that it can be compared with this value. This is resistance ratio, which the value which you have taken from this solid curve, that is resistance ratio. One CSR cyclic stress ratio you have calculated earlier for after dividing it by magnitude scale factor. Now you are to, these are the curves by other investigators. Now you are to calculate factor of safety. Factor of safety will be CRR over CSR. CRR is the value of CSR which you have calculated from solid curve, which I have shown you the figure. Corresponding to N160 CS from the solid curve, you have calculated one value of CSR, that is CRR, that is resistance ratio. One CSR you have calculated from the equation. Then the value which you have calculated from the equation divided with magnitude scale factor to convert it to equivalent 7.5 magnitude earthquake. That is your CSR. So CRR divided by CSR will be factor of safety against liquefaction. If this factor of safety is more than 1, then liquefaction will not take place. Otherwise, liquefaction will take place. This is how we check for liquefaction, how to evaluate liquefaction potential. Standard penetration test is performed, N values are recorded, that is NM, then N160 is calculated using equation nm multiplied by various correction factors. Then N160 is converted to N160 CS, that is clean sand. Then from the curves given by seed ATAL corresponding to N160 CS, you calculate the value for clean sand curve, solid curve, which will give you cyclic resistance ratio. One cyclic stress ratio you will calculate from the equation which I have shown to you. After calculating sigma V0 dash RD and assuming A max value, you compare CSR with CRR, calculate factor of safety, that is CRR divided by CSR. If this factor of safety is more than 1, then there will not be liquefaction chances. If it is less than 1, then chances of liquefaction will be there at the site. If chances of liquefaction are there, then the measures which I have told you, densification or some structural changes, they must be adopted. Just to make you clear, suppose we have n value from the SPT 12, 60% efficiency hammer was used, the length of rod 10 meters, borehole dia 127 mm, so soil strata 3 meter thick stiff clay, overlying 3 meter thick sand deposit. Below sand strata is rock, water table is 3 meter below ground surface. If you have actual problem from the field, design earthquake has been designated as moment magnitude 6.75, maximum ground acceleration is expected to be say 0.35 g. Calculate factor of safety against liquefaction. Suppose this is the data which you have collected from the field. Now what you will do, effective overburden pressure you will calculate at the center of the sand layer. So gamma into Z, below the water table gamma submerged 21 minus 10 kar diya, 9.81 or 10 into 1.5. Similarly, total average pressure sigma V0 you will calculate, that will be 20 into 3 plus 21 into 21 plus nahi hoga, 21 into 1.5. So 21 into 1.5. In effective it is 21 minus 10 into 1.5. In total it will be 21 into 1.5. So stress reduction factor from the equation you can calculate 1 minus 0.00765 Z. So stress reduction factor RD you can calculate. Sigma V0 you have calculated. Sigma V0 dash you have calculated. CSR you can calculate after substituting the values in the equation, that will come 0.263. Now N160, that is measured value, that is given as 12. Then CN, CE, CB, CR, CS values taken from table. So corrected value N160 comes out to be 13.8. Then N160 CS is calculated for fine contents of 15%. Alpha and beta, they are calculated. Substituting the values in the equation, we can calculate N160 CS. So now let us say that is 17. Now from the curves corresponding to this N160 CS 17, your CRR value you can calculate, that is say 0.185. Magnitude scale factor, if you see from the table, that is 1.31. Because your earthquake expected is 6.75, we will convert to 7.5 magnitude earthquake. So magnitude scale factor will be used for calculation of CSR. So factor of safety here therefore comes out to be 0.92, because factor of safety is less than 1, therefore liquefaction will take place. Liquefaction is expected to occur if you have such type of strata. So another method is evaluating liquefaction potential by cone penetration test. Static cone penetration test can also be performed, like SPT, standard penetration test, is performed. Static cone penetration test, if you remember, cone is there instead of standard split spoon sampler. We use cone with apex angle 60 degrees and base area 10 centimeters squares. So that cone first moves for approximately 40 mm into the ground. Then cone plus friction jacket assembly together they move for next 40 mm. So that will give you skin friction load plus point load. First reading will give you point load only. So difference will give you only friction load also. Then arrangement mechanism is made such that now for 80 mm outer cover only, outer tube only moves, and then for again for 40 mm only cone moves. Then friction jacket assembly plus cone combined they move. So like this you can calculate point resistance values QC, and you can calculate friction resistance values, skin friction load also from this after performing the static cone penetration test. If you remember, static cone penetration test is performed like this. Cone is penetrated into the ground step by step up to the desired depth. Truly normalized dimensionless cone penetration resistance corrected for overburden stress QC1N. That is QC you have calculated, you have observed values from the field. As in previous case, you were having N values from the field, that was Nm. Here you will have QC values from the field, cone resistance. So that will be first converted to, earlier we have converted N value to N160. Here this QC will be QC1N. QC1N is CQ into QC upon PA. PA is atmospheric pressure, 100 kN per square meter. QC, whatever you have observed after performing cone penetration test. So QC1N can be calculated. So after calculating QC1N, this CQ is PA over sigma V0 dash. Sigma V0 dash is similarly calculated as effective overburden pressure in kilonewton per square meter. Sigma V0 dash value, PA over sigma V0 dash raised to power N. This N for sands is taken 0.5. So PA over sigma V0 dash raised to power 0.5. That will give you CQ. So substituting the value of PA, QC and CQ, you can calculate QC1N from this equation. So when you have QC1N, then from this curve, you can have value of cyclic stress ratio, CSR, that is CRR. CRR now you can calculate from this corresponding to QC1N. You will get value of cyclic stress ratio from this curve. Similar curves are given by other investigators also. So normally we use this curve. Okay. So these are different curves given by different investigators. So from these you can calculate CRR. CRR value you can take from the curves. CRR curve can be approximated by equations also. You can use curves or these equations. CRR curve can be approximated by the following equations. If QC1 and CS is less than 50, then equation is there between 50 to 160. Another equation is there. Clean sand cone penetration resistance normalized to 100 kPa is QC1N. QC1 and CS is KC into QC1N. So clean sand, जैसे हमने पहले convert as earlier, as we have converted N160 to N160 CS. Similarly, this QC1N will be converted to QC1N CS. So for that we need KC. KC will be depending upon another factor, IC, as given in this equation. There are some equations which you need to use for calculation of this QC1 and CS. IC can be calculated by using this equation. FS and QC values you have from static cone penetration test data. You can use that in this equation. Then calculate IC. And if IC is greater than 2.6, soil is classified as clay and it may be too plastic to liquefy. And if IC is less than 2.6, soil is most likely to be granular. And Q and small n should be taken 0.5. As earlier also I have told you, it is taken 0.5%. If your value is more than 2.6, soil is likely to be very silty and possibly plastic. So QC1N should be recalculated with an intermediate value of 0.7. If it is silty, for QC1 and CS, CRR can be determined from the curves and factor of safety we can calculate as we have already calculated in case of SPT data. Same equation we will use for calculation of CSR. Then CRR from the curves which I have shown. So CRR divided by CSR, that will give you factor of safety against liquefaction when you have data of cone penetration. So cone penetration test data can be used for now liquefaction of clay soils is possible considered if all the following criteria are met. The weight of soil particles finer than 0.005 mm is less than 15% of the dry weight of soil. Liquid limit of soil is less than 35%. Moisture content of soil is less than 0.9 times the liquid limit. Clay soils not meeting all these criteria may be considered to be non-liquefiable. So most of the times if clay soil is there, that is non-liquefiable. Fine sands, they are considered most susceptible to liquefaction. So SPT or SCPT is performed at the site, data is collected, the procedure I have told you, steps for calculation of CSR and CRR. Then you have to calculate ratio CRR divided by CSR. If that ratio comes out to be less than 1, then there will be chances of liquefaction. Otherwise, liquefaction will not take place if it is more than 1. Then liquefaction will not be expected at that site. If it is less than 1, then proper measures should be taken for densification or for proper foundations. Then we have earthquake-induced settlements. Earthquake-induced settlements The tendency of sands to densify when subjected to earthquake shaking, that is well documented. Subsurface densification is manifested at the ground surface in the form of settlement. Earthquake-induced settlement frequently causes distress to structures supported on shallow foundations, damage to utilities that serve pile-supported structures, damage to lifelines that are commonly buried at shallow depths. Dry sands densify very quickly. Settlement of dry sand deposit is usually complete by the end of an earthquake. The settlement of a saturated sand deposit requires more time. Settlement can occur only as earthquake-induced pore pressures dissipate. Time required for this settlement to occur depends on permeability and compressibility of soil and on the length of drainage path. So I have already discussed this while talking on factors affecting liquefaction. It can range from few minutes up to a day. Estimation of earthquake-induced settlement sands is difficult. Errors 25 to 50% are common in static settlement predictions. Even less accuracy should be expected for more complicated case of seismic loading. So earthquake-induced settlements procedures are there, but these are very approximate values. You can say errors are up to 50% or even higher sometimes. So first we will talk about earthquake-induced settlement of dry sands. Densification of dry sands subjected to earthquake loading, that depends on density of the sand, amplitude of cyclic shear strain induced in the sand, number of cycles of shear strain applied during the earthquake. At any given depth, effective shear strain may be estimated by the relation we have. Gmax is shear modulus at low strain level. Effective shear modulus at induced strain level, G effective. Tau average is average cyclic shear stress at the corresponding depth. So this equation is used for gamma effective calculation. Gamma effective into G effective over G max. This equation number 2, 0.65 A max upon G sigma V0 RD over G max. Takimatsu and Seed, they have given this procedure. G max can be calculated using the equation 20,000 N160 raised to power 1 by 3 sigma m dash raised to power 0.5. Sigma m dash is effective stress on the soil at the given depth. Effective overburden pressure that you can calculate sigma m dash. N160 already in SPT you have calculated N160. That N160 will be used for calculation of G max. G max will be 20,000 N160 raised to power 1 by 3 into sigma m dash raised to power 0.5. So G max can be calculated from SPT data. Having computed gamma effective G effective over G max from the equation given, curves after Takimatsu and Seed may be used to determine gamma effective. Knowing the effective cyclic shear strain, volumetric strain can be estimated by using the curves. Curves are given, these curves are there. Effective strain, gamma effective versus gamma effective G effective over G max. So gamma effective into G effective over G max you have calculated from the equation given by Takimatsu and Seed. After calculating this gamma effective into G effective over G max from these curves corresponding to the value of sigma m dash, you can calculate gamma effective value. These curves are given. From these curves, you can now calculate effective shear strain gamma effective. After calculating gamma effective, now you can calculate volumetric strain epsilon C. Volumetric strain epsilon C can be calculated after knowing gamma effective. Gamma effective here, that is shown here in the figure along the x-axis, cyclic shear strain, gamma cyclic. that is gamma effective, which you have calculated from the previous curve. From the previous curves, you have gamma effective. Now, corresponding to gamma effective value, here two set of curves are there. One is for N1 values, N1, 40, 30, 20, 15, 10, 5. The other one is for corresponding to relative density values. Whatever you have with you, you can use the curves accordingly. If you have N1 values, if you have performed SPT, you have N1 values. So your N1 value is 20, you will use the curve third from the top like this. Corresponding to that, you can see the value of volumetric strain due to compaction. So once you calculate volumetric strain from this, after calculating volumetric strain, that is epsilon C, after calculating epsilon C, volumetric strain now can be converted to an earthquake of magnitude 7.5 by using these magnitude scale factors. Again, here magnitude scale factors are given. Whatever value of epsilon C you will calculate from the curve, that value will be divided by this magnitude scale factor to get gamma epsilon C for an earthquake of magnitude 7.5. Estimation of earthquake induced settlement now can be made once you have epsilon C. When you have epsilon C, that means volumetric strain you have, amount of settlement due to earthquake shaking can be calculated by multiplying the volumetric strain by thickness of sand. Strain multiplied by thickness of sand layer, that will give you settlement. So like this, you can calculate settlement. Similarly, one field problem we have, let us suppose we have to calculate settlement of 15-meter thick deposit of loose sand. Gamma you have. After performing SPT, you have N value 9, earthquake magnitude 6.75. So that this data you have. Then you will calculate like this. First you will calculate G max. You can now calculate, because 15-meter thick deposit is there, we will divide it into 5 layers of 3 meter each. Gamma for each layer is same 1.6 kilonewton. This is not 1.6 kilonewton, it should be 16 kilonewton per meter cube. 1.6 likha gaya. So N160, that is given 9. You can calculate sigma m dash up to the center of each layer. Then you can calculate G max using the equation. Then after that, you can calculate gamma effective, G effective over G max. That equation was given to you. Then gamma effective from the figure. Then from gamma effective value, you convert to 7.5 magnitude earthquake, dividing it with magnitude scale factor. Then epsilon C. Here, the epsilon C value, what you have got, that will be doubled. Another instruction is that we should double that value. Here it was following the experimental results of AICTE 1975, the effect of multi-directional shaking is accounted for by doubling epsilon C value. Yeah? Effect of multi-directional shaking, because we have might have multi-directional shaking. So by considering multi-directional shaking, epsilon C value, which we will calculate from the curves, that should be doubled. So this is epsilon C value multiplied by 2. So that's why here in this table I have written 2 epsilon C, 2 times. So epsilon C will be doubled, then multiplied by thickness of sand layer. That will give you settlement. Like this, you can calculate settlement. There are other methods also. I think this much is sufficient. Now you can have your queries if you have any. Another approach is also there for calculation of earthquake-induced settlements. We can calculate post-liquefaction volumetric strain using these curves. Different curves are given by Ishara and Yasmin also. This can also be used. So let's talk about some recommendations for earthquake-resistant foundations. Loose fine sand, soft silt, black cotton soils, expensive clays should be avoided for foundation. If unavoidable, building shall rest either on rigid rock foundation. Foundation should preferably be designed as continuous mat or raft in order to avoid relative horizontal displacement. It is recommended that parts of building foundations which rest on soils of different types should be designed as separate units. Okay. Now,
Thank you, sir.
Questions?
Yeah, thank you for making us learn about liquefaction and various parameters, factors, equations related to it. So, dear participants, if you have any question regarding the same, you please can ask our speakers. Sir, before anyone comes up, I have a question. Liquefaction is being studied for a long time now. And I think previously I was in California, so I think they have also contributed in a significant way in the research related to liquefaction. So my query or suggestion from you is, like, what are the research gaps in this area till, that can be taken up these days also?
Actually, all these methods which have been given by mostly sea literates and tech market, there are 2, 3, 4 people who are working on this. All these are very, very approximate values. They are approximate procedures only, based on some field observations, supported by some lab experiments. Errors, as I told you, in settlement calculation, errors are in the range of 25 to 50%. Very high errors. So there is scope to precisely calculate these values, add some more factors, consider some more factors with different assumptions, with different data from different earthquake sites that should also be considered, so that more accurate equations, we can dwell. These are very approximate equations which we are having now till date.
Thank you, sir. Thank you. So, I think there's a question in the chat box. Dr. B. Mahalingam. I'm sorry if I have pronounced it wrong, but Dr. B. Mahalingam would like to ask that in the site there is a pond with full of water, and if it is suddenly drained, what could be the effect over the adjoining structures? I think that's a question from one of the participants.
Actually, this is similar to sudden drawdown condition as in case of ACTE dams. And sudden drawdown condition, there will be suddenly water lowers, but pore water pressure still remains. That will not be dissipated in such a small span of time. So high pore water pressures will be developed. Due to high pore water pressures development, there will be loss of shear strength, and chances of that side of the pond collapse may take place. Shear strength will be reduced tremendously due to sudden drawdown.
Yeah, so I think thank you for answering that question, sir. Any participant having any other query, please raise your hand. I can unmute you. Else, you can always reach out to Professor Agnihotri through his email ID that is available on the website of NIT Jalandhar. And I think he would be really, happy to answer your queries regarding the same. Yeah, Doctor. I think there's one question. Let me just unmute you. Yeah, sir, please go ahead. Dr. M. Nagesh, please go ahead.
Hello, yeah. Sir. Hello, sir. Can you hear me?
Yeah, you're perfectly audible. Go ahead. Yeah.
Hello, sir.
Okay. Yeah, we can hear you. Go ahead.
Okay, sir. Sir, whatever I feel is the disasters, whatever it is happening, whether it is earthquake, landslide, etc., or is just due to the bad application of engineering knowledge and principles which already we know. Like, for example, in the landslide, if we take the vegetation which was covering that slopes, now we are eroding it, and then we are inviting a problem. So what my question is, it is the disaster resilient structure, etc. This is my opinion. What we already know certain things which we should not do, but still we do those things, and that is what is creating the problem, sir. What is your opinion, sir?
No, I agree with you. That's what I said earlier also, that in most of the cases, they stress on earthquake resistant design of structures. People think that if structure is properly designed by considering the earthquake forces, now it is safe. But they are not considering this very important factor, that is liquefaction, which may take place. Mostly when studies are soil investigation studies, they are carried out, people normally get bearing capacity, that's all. Request comes for bearing capacity calculation. They simply say that perform SPT and get us bearing capacity. They never say that to check the liquefaction potential also. Only very rare or very few people, they come with this request that liquefaction should also be studied. 99% cases I have observed during providing consultancy, that people only they just want to fulfill the requirements while knowing simply bearing capacity. That's all. This is the problem. I agree with you that there are existing techniques, but they are not being properly applied.
Mm.
There should be some
Uh,
government instructions.
and also, just to give an example, the road construction they do,
Hmm.
the road construction, the main fundamental things is the road water should not be stored on the road surface.
Hmm.
But the way the roads are built, the water will be standing on the road itself without proper drainage. Drainage will be above, and then the road will be below. Now, what my point is that it is something to do in the right in the undergraduate level or postgraduate level. Whenever this being taught, what are those things which are important for a designer that has to be emphasized in the undergraduate and postgraduate courses, which is not done at present. We teach them the students, but then we don't show them what are the important things which needs to be followed, principles which needs to be followed. But
No,
how do
actually,
we bring this into the curriculum? That is where we as a faculty. Yes, sir. Yes, sir. Go ahead.
actually, these are all already there in the curriculum, I suppose. At least in post graduation, in MTech programs, we teach
But
them everything, but they are not actually followed in the field.
what
Students,
is
when go to the field, then they
what
think
is
that whatever teacher was saying, whatever they have taught us, that was just to get marks.
hmm,
There they start applying their own techniques.
uh,
Whatever practice is being followed from last 10, 40, 30,
yes,
40 years, they keep on following the same.
yes, yes.
Actually,
How,
there is need to change the mindset of the young people.
okay. How do we do that? That is a challenge.
Actually, when we teach them, then
Hmm.
some moralistic lectures, some
Hmm.
value lectures, value based lectures, they should also be included,
Okay.
not as part of curriculum, but every teacher should have uh, given some tips, some ideas, some discrepancies which are being observed. Like you are saying that you have observed something, you should must share with your students,
Hmm.
with your colleagues, that this should not be done. When you go to the site, when you will become in charge of some project, then you should take care of all these things. Such lectures, if we give them,
Hmm.
some of the students, I have observed that some of the students must follow. They,
Oh.
I know some students, when I have given them some such lectures, after joining their jobs, they have uh, told me that, sir, whatever you told us, now I am following that in the actual practice.
Um,
Maybe 1%, 2%, but some students, they
yes.
listen to your advice, not all.
Why I brought this point was I was in the Gujarat when earthquake happened.
Mhm.
So immediately for 6 months, everyone was very alert and etc. After 1-2 years, then they were reverted back to the same normal practice of which was earlier 2-3 years back.
This is the
Uh,
problem actually.
so that's why I just brought it to the point. Thank you, sir.
Thank you very much.
Thank you to sir again. So I think we can conclude the session, sir. So if there is any other question from anyone, you can always write to Professor Agnihotri through his mail. So thank you once again, sir, for taking out time from your busy schedule. And I thank you on behalf of organizing committee for delivering this lecture, and expect that next time you will be in person in Shimla for delivering another lecture in another conference or workshop. With these words, I thank you again, sir. Thank you, sir.
Okay, thank you, Dr. Mahesh, for inviting me for this lecture. It's always pleasure to deliver lectures and share whatever knowledge I am having, to share that knowledge with students, with my colleagues. That is pleasure to me. Thank you.
Thank you, sir. Thank you once again. So, Professor Agnihotri, you may leave and we can continue further. Thank you.
Thank you.
Yeah. So, dear participants, our next lecture will be by Dr. Hemant Kumar Vinayak, who is Associate Professor at the NITTR Chandigarh. And he's having very wonderful topic to cover in his lecture. That is regarding non-engineer construction theory to practice, something field engineers love to talk, but when academician talks, then he also tries to keep in mind the theoretical fundamental concepts behind it. So we'll be joining back at 1:15 p.m. for his lecture. I'm also keenly looking forward to hear from him. So you all are requested to not leave this meeting, but be part of this meeting. And then we can start our next session by 1:15 p.m. So all are requested again to join back by 1:15 p.m. But you are requested not to leave this meeting. Okay, because attendance is being taken automatically. And then there are some guidelines by AICTE that you must have at least 80% attendance, minimum attendance, and 60% marks that you have to score minimum. So then only you are eligible for certificates by AICTE. So that's my request again. With these words, I thank you again and see you at 1:15 p.m. Thank you very much. Very good afternoon to everyone. We'll be starting our session in next 5 minutes because only 64 participants have, I think, joined right now. So we are having around 120. So we'll wait for 5-7 minutes more. Thank you. Dr. Hemant has joined us, right? Dr. Hemant, can you hear me?
Yes, I can hear you.
Okay, okay. So I think we have all are there. So much. Thank you. So good afternoon, everyone. Dr. Hemant, you can hear us properly, right?
Yes.
Okay, that sounds good. Okay, so I think I was expecting that all the people will be able to join because only 65 participants are right now there, and we were expecting all to join by 1:22. It's already 7 minutes late, but we want that everyone should listen to Dr. Hemant because what he is presenting, will be presenting, is something that we can't find in books or literature generally. So that was the reason that I wanted that all must join, but okay. So we'll wait. I think Dr. Hemant, we can wait for 1 minute.
Okay.
Yeah, yeah. Thank you. Okay, I think we should start. A very warm good afternoon to everyone. I hope that you had a wonderful lunch. We have with us today's second speaker, Dr. Hemant Kumar Vinayak, who is joining us from Chandigarh. And presently, he's associate professor in entrepreneurship development and industrial coordination cell at National Institute of Technical Teachers Training and Research in Chandigarh. He has done his PhD from Department of Earthquake Engineering, IIT Roorkee, and his area of specialization includes entrepreneur development, industrial coordination, earthquake engineering. Dr. Hemant was previously working as a teacher in NIT Hamirpur. So he has, and he has, and will be having a very long association with Himachal Pradesh. And the great thing about him is that he's very much oriented in his research towards field. So what exactly, the demand from the government departments, industry comes up. So Dr. Hemant takes care of that. About his teaching experience, he has more than 13 years of experience in academia and around 3.5 years of experience in industry. He has guided around 4 PhD students, 17 MTech students, and published more than 30 research papers in prestigious journals, conferences, and workshops. He has also completed large number of industrial and research projects, around 12, having value, I think one of them was around 40 lakh rupees. that was sponsored by HPS DMA, that is Himachal Pradesh State Disaster Mitigation Authority, and they're very much always, because whenever I talk to disaster mitigation, they always tell me about Professor Hemant. So always they are like always congratulate that okay, these kind of professionals or academicians are also there who are able to cater the needs of state government officials, industry people, and also the academia. And for his work, he has received Himachal Pradesh State Innovation Award for the year 2014 and 15. He has around 7 copyrights with him, delivered more than 100 lectures, organized more than 100 various activities till this date. So with these words, sir, I welcome you to this third day of faculty development program on disaster resilient infrastructure, where it would be our pleasure and would like to listen from you about the topic non-engineered construction theory to practice. So thank you once again for accepting our invitation, sir. And with these words, over to Professor Hemant from NITTR Chandigarh. Thank you very much, sir.
Thank you, Dr. Mahesh, for giving me the opportunity to share my experience, what I gained during the last 12 years when I was in NIT Hamirpur. Is my screen visible?
Yes, it's perfectly visible, sir. Go ahead.
So I will be switching over from my presentation to some of the documents as well. So I go to the slideshow first. So this is my topic, non-engineered construction theory to practice. For those who can read Hindi or understand Hindi, they can go through some of these particular lines which I have actually included. When I see the construction now, most of my presentation or almost all of my presentation will contain the photographs of the state of Himachal Pradesh, because that is the area where basically I have traveled a lot, and whatever the experience that I gained was from this state only. Although there was some particular experience from the northeast as well, but those were only for imparting the trainings to the engineers of northeast. So this is what the earlier constructions that you can find in the society, that is the mud type construction, which we call it as non-engineered, because you don't do any analysis for this kind of a building. Even you can find such construction which is called as Dhaji Diwari. Mostly these construction you can find in Jammu and Kashmir area, and this construction evolved to make the structures earthquake resistant with these cross members acting as bracings. And you just Google out Dhaji Diwari and you can find lot of documents in this particular case. Then the third is a combination of this bottom portion where you find this window. This is a Katkuni construction, a very typical again earthquake resistant construction of the state of Himachal Pradesh, with the combination of this Dhaji Diwari above it. And again, this particular pattern of construction evolved again as an earthquake resistant feature. But if you see all these particular left side figures, this is a combination of mud, some random rubble stone, and then the third component is the wood. Now this wood is basically a procurement is a problem nowadays, availability is an issue, and this is the reason that this pattern of construction, then nobody wants to live in such kind of mud type of construction. They say that it looks shabby, although when you talk in terms of temperature, then these are much more comfortable with respect to the RCC construction. And what you see is the growing popularity on the right side is these soft story structures. Then this is a stone masonry structures, a typical construction of Public Works Department of Himachal. And then the masonry construction in the state of this hilly regions, you don't find the brick manufacturers. So you will find all these nearby states, that is Punjab, Haryana, these provide them the bricks. And so this is what the type of construction that you see are growing, are having the popularity nowadays. But again, when you talk about these particular construction, if I've started talking about non-engineered construction theory to practice, the unfortunate part is that most of our civil engineering includes analysis, design, high-end research, and so on. But when you get into the real societal picture, you will find that a very different picture is there in the society. Now, Sendai framework for priority for action. The priority number 3 said was that investment in disaster risk reduction for resilience, public and private investment in disaster risk prevention and reduction through structural and non-structural measures. Now, these are the two most popular cities with respect to tourist destination. One is Shimla and another is Dharamshala. But if you see this particular buildings there on such a slope, one can make out that even if he has made any particular person has made his building earthquake resistant, it is all that most of the people, when I interact with them, they only say that here, if anything comes up, the most important aspect will be to see that how the domino effect is going to play here. So that is the kind of a scenario that is there in the hills. That is, the buildings are all across in the slopes, and even if one or two buildings start tumbling, they will take all those particular buildings along their line. So that is what we say, that whatever the constructions that you have done, we'll have to see whether we will be able to change the scenario. Now, that was the construction within municipal area. When I get more deeper into, when I say that why the domino effect will take place, so it is all because you have such thin columns, and then the pattern of construction that you see in the society is that the owner, the very frankly architect, they want very thin columns, and but whatever the thickness of beams or the depth of beams or the slab is there, it hardly matters to them. And so this is the reason that these strong beam and weak columns, even though the codes are there, but still you hardly find their effective implementation in the society. And then obviously this is the scenario of a Burj, which talks about that, look, if there is another earthquake near in Himachal Pradesh, then you'll have something a similar scenario, which we have already witnessed something around 20 years back in India. So Indian standards by BIS, IS 456 2000, 1893 2022, and 2016. Although these particular codes exist, but then their implementation is questionable. And my lecture is basically focusing upon the implementation of those codal provisions or those documents which are there existing with us, either on in a hard copy or a soft copy. What about their implementation? This is engineered construction. Why I say this is an engineered construction? Because I see that these are RCC columns and beams, and then obviously infill walls are there. But then the engineered construction becomes questionable when I put my hand there, which is of 9 inches, and then you start finding 9-inch columns. So, but although the codes have come up, saying that look, the minimum width of the column should be of 1 feet. So then the question occurs is that well, is that normally I tell to all the faculties that kindly give your students the assignment with respect to field. Ask them to take the measurement of the buildings that is undergoing construction both within municipal boundaries and beyond municipal boundaries, and just ask them to cross check whether the column width is less than 300 or not. So if it is less than 300, the next question comes is that who are the officials who are giving the approvals for the column which is less than 300? Then this picture so talks about that look, if you want to construct columns, it is not necessary that you have to procure the shuttering every time. You can simply use a 6-inch pipe as well, put up the steel in between and go for construction of such kind of columns as well. This the concept of those putting up the line of forces along one particular line and then analyzing those things can be removed when you talk about construction beyond municipal boundaries. You put up two columns, another columns can come here and then another in a random fashion. So one really doubts that if you do the analysis of these kind of structures, are they safe enough? This pattern of putting up masonry columns, although my major part will be for with respect to these photographs only, that I would like to question those some of the engineers that we have never been able to analyze these masonry columns in the RCC structures. So the question is that those things which cannot be analyzed, how do you see it in the society? So then this is another same thing. You find two columns here, one column here, and then one column here. Although this clearly shows that this is a masonry column. So construction practice concerns and the powers. So here IS 13920 says that look, the minimum if you are having a beam steel which is of 16 means the maximum diameter is 16, then the minimum column dimension is 320 and and then if you are having a 20 again beam steel, then the minimum dimension is 400 and if 20. But the question is that although this is given in IS 13920, then but are these really being implemented when we are designing the buildings? This is that particular clause 7.1.1, which says that the minimum dimension of a column shall not be less than 20 times dB, where dB is the diameter of largest diameter longitudinal reinforcement bar in the beam passing through or anchoring into the column at the joint, or 300 whichever it is. When you come to Himachal Pradesh, tourism is one of the major things with which the state runs, and the HPTT executive engineer says that look, the hotels will lose their sleekness actually. But then we said that हालत मुझे कितना मजबूर करती है, इल्म नहीं उसे वो मुझे मजबूर करती है. So that's what the power I say, that when you force us, we are going to modify the system of construction. So construction practice concerns and then the suggestions. RCC construction practice was basically for high-rise construction that is above 4 stories. But we unnecessarily forced it to 1, 2 or 3. When I was in NIT Hamirpur or my previous institution, I designed a lot of buildings where I was asked that look, although you are finding these as architectural drawings with masonry, but we need RCC construction there. So the point was that when you are having only 1 story or 2 story, why do you want to, invest much more? Because your masonry construction, as we say, that it is 30% cheaper than the RCC construction. That's what the normal thumb rule is. So wherever I used to say that, look, wherever you have some small parts of the districts are there, you wherever possible go for those masonry construction or confined masonry. And for beyond, for if you want to really go for four-story building, go for confined masonry. Otherwise, masonries can be structures can be there basically for 3 stories and 4 stories. And the next point was that why I am talking about this is because when you talk about RCC construction, then in the case of RCC construction, we require soil bearing capacity. And let me tell you frankly, in most of the situations, soil bearing capacities are assumed based on some particular testings which has been carried out by other departments, and we assume a standard value. So normally you will not find any of the private owners going for such soil bearing capacity. With the zone factor, importance factor, response reduction factor, design acceleration coefficient, well, we come out with design acceleration spectrum. That is the pattern or the parameters with which we come out with this value. And then you use live load, dead load, seismic weight is calculated, and then your earthquake load is a product of design acceleration spectrum and the seismic weight. Then you use a combination of live load, dead load, and seismic load with a factor of safety on the building frame with assigned section, concrete property, will provide me the bending moment and shear force, which is calculated by computation through the stiffness method. Bending moment and shear force will then provide me the longitudinal steel and the stirrups. If the section is okay, go ahead for drawing or revise. So this is the standard, methodology what we have been taught or what we are teaching in the classrooms to our civil engineering students. So the construction practice concerns and suggestions. What I want to say is that this reinforced cement concrete construction is a civil engineer's job and not of mason oblique the owners. But we have taken up these constructions for granted, and this is the reason that we have made a mess of it in the society, especially in Himachal when you move across with these kind of buildings. I moving from my institution to a place where I have to give a lecture, and then I see a building with some columns, and there are 2 columns which were fortunately not plastered at that particular time. I got the photograph clicked up. Now my next question to the participants is that kindly give this structure for analysis to the students, asking them that the constraint is that these 2 columns should be of masonry and not RCC. Sorry, not yeah, not a column with the concrete and the steel. And please ensure that this building is able to safely bear the load of an earthquake when we do any kind of analysis. I come to the next structure where fortunately I do not have the slab. It is only connected with the beams, but all my columns, instead of being RCC columns, they are again of masonry. Again, this kind of problems can be given to the students for analysis. Well, these are not hypothetical problems. These are real practical problems which are there in the field. This is another, this structure is basically overruling all those concepts of, L by D, all those particular slenderness ratios, right from having a masonry column, right from this particular landing and going to this particular top. So although we may our basically calculations might fail, but then the masons and the owners, these two coupled people have actually given us such kind of things in the society which as a civil engineer we do not imagine. And this was when I was moving from my institution to a place Solan to give part the training to the masons. This is a complex, a shopping complex, maybe U-shaped, and the again my movement was from my own institution to a place in Chamba where the bridge has failed. And in this particular case, the surprising part is not that you find the masonry bricks at the bottom, but the surprising part is that I find the steel here, something like this. So I fail to understand that how do you get such kind of constructions carried out. Again, you can give such kind of you know assignments to the student to see that what could be the failure pattern of such kind of constructions where you have such masonry columns in the ground floor, and then I don't know if these are RCC, but then you find the steel there actually, just to show to the owners that look, there is a steel here which is there in the column. Now in this particular case, since there was no staircase, so there was no requirement of any column below it. But since I have a staircase here, so I'll put up a column here. But since there was no column which was coming from the ground, so I convert this into a masonry one. My again question is that a person who is living with this particular double soft story, the point is that first of all, this itself may not be safe. Above that, added up to this, so it needs to be checked that whether this is again an assignment that to check whether this particular structure has a life safety or whether the person will be able to easily evacuate even if we install the early warning system in the state of Himachal Pradesh. This is another structure. I am moving from one place to my home institution, and I see a beautiful building with the stilts, ground floor open, but there are two columns which are there in the masonry. Again, another question is that we question the soft story itself, and the point is that how what is the magnification of questioning this kind of a building where instead of having the column as some reinforced cement concrete, we are having a masonry column there. So with this, another photograph is there. I'm moving to Dharamshala, and this was day before my lecture there at Dharamshala, because 4th April is the day when you had the Kangra earthquake. And so before that, I'm clicking this particular picture near the institute saying that, look, these are all those particular masonry columns coming up. So, well, for me, analysis of such structures is beyond the scope of syllabus of BTech Civil Engineering. My big question to the TCP is will why it is silent about this construction. Structural stability certificate is the issue. See, I'm showing you a form which any particular civil engineer signs it before that gets constructed in the municipal area. Now, this is the form for of structural stability certificate and soil investigation report. I/we hereby certify that the building of Sri this proposed over Khasra number this, Mauja number this, or ward number this, Tehsil this, has been designed by me or us as per the Indian standards against the natural hazard, including the earthquake protection and after soil investigation. The building is safe. Now the question is that when I'm signing this particular document, I normally say that the building is safe on the paper, because when as a civil engineer you are asking me these kind of a certificates where I was not involved as a site supervisor, or maybe that you are expecting that I'm supposed to supervise those particular sites and so on. But I have shown you a lot of examples with the engineers taking up multi-dimensional, work parallelly. I don't know to what extent these kind of, because these kind of structural stability certificates are required while you are submitting that particular drawings. So that is what is the major issue which actually is there when I talk about the constructions. Then I'm talking about another construction, that is I'm moving towards my again institution to the Shimla, and this is what is a copy of confined masonry. Copy in the sense that you are making up a column with all those particular flush surface. There is no interlocking of these bricks with the columns. And but before you put up the beams so that this can be an RCC structure, you are constructing a wall. And then what you will do, then you will put up the reinforcement of the beam, and then do the concreting. The point is that what kind of structure is this, where instead of the load getting transferred from the slab to the beam and then beam to the column, the beam load itself is getting rested on this particular wall, and then you will be putting up a slab. So again, you can have another problem to the students saying that, look, I have made the columns, I am now putting up the walls, now you put up the beam and then the slab, now do the analysis for such kind of structure. So you can have a comparison between two types of buildings where you are designing it in a normal fashion, and another where you are putting up a bricks, this particular masonry wall, then the beam reinforcement is there, because you do not have a shuttering here, because otherwise if you put up bottom shuttering you will not be able to remove. So in this particular case what actually happens is that your beam is basically your concrete is integrated with this particular masonry construction. So we come to this now. Let us come to this particular link of one of the websites of town and country planning, from where basically you will come to know that this is, I'm just showing you because I have got these things done, that is talking about acts and rules of various states. So this is where your Department of Town and Country Planning, you have HPTCP rules, notification regarding these and so on are there. And then here, this is that particular document. Let us open up this particular document, page number 6 and 47. So I'm moving to this page number 6. Now it is here that my question will be that when you have seen so much of construction, this is the the institution takes up the fees outside the municipal boundaries, that is 6 rupees per square meter, other residential area 8 rupees per square meter. Whenever I have started talking about, I even talk about policy issues. I rarely now talk about analysis, designs, and those things, because those things are good and okay when you want to talk about for a very defined constructions where you already have the engineers involved. But let us talk about more than 60-70% cases where your engineers are not getting involved. Masonry is getting converted into RCC structures. And then if I talk about this 5 rupees you are charging for a municipal area. If I talk about standard building plots that are being constructed in and around here where I'm staying, Chandigarh, where you have an area of 23 feet by 60 feet, means something around 1500 square feet, maybe something around 140 rupees a square meter. And then you talk about some building permission 5 multiplied by those 140 itself, you are talking about something around some 700 rupees or so on. My question is that is, and what is the construction at the moment, the field construction including material and other things, that is around 1800 rupees a square meter. If I reduce it with respect to rural, how much it will be? Maybe I can reduce it to, instead of 1800, I will be talking about 1500 rupees a square meter. That's it. So the point is that at one side you are charging only 5 rupees for all these building permissions and so on, and the owner is spending around 1500 rupees per square meter for getting it constructed. And you say that look, there is no authority which is responsible for you to have a very good designs and so on. Look into the market, who are the structural engineers, and then get it done by, and then look into the market as well for good masons who can give you the construction. So that is where the problem is. And then there are points that yes, the websites do have such kind of information, but unfortunately those do not get translated into actual implemented scenarios, or basically an aspect that yes, everybody knows that where the information is and I can use that appropriately. Why I'm saying this is, and then even look, let us now look to the second phase, that is page number 47, where basically this particular document is having that same certificate which I showed you earlier. So why I was saying this was because you find these RCC construction along those particular hills, and then inappropriate practices are there, that you have a building like this or like this, but then since the owner says that, well, I do not have so much of amount to construct this whole building, because your along the hills your construction is going to be like this, you need to come up from the bottom and then come up to the road level such that you can connect it. And then at the moment, whatever is my useful requirement for this is I will be constructing those enclosed area as my shops. But now let us pick up this particular beams here for our own analysis. Now what these beams are, that you do not have a concrete here, you have only a stirrups and then the reinforcement of them. Again, what you can do is that you give your students such that we don't go by the normal those kind of stress strain relationships which you will find in any of the RCC book when we are teaching the students, saying that look, you have a compressive stress on the top fiber and then it goes to a neutral axis and then lateral. You just say that look, there for 2 inches there is no concrete, stirrups are in the air, and now do the analysis and then see what kind of detailings you are going to get. So this is another thing that you will find in the society, that people move by their own. So existing, this is the reason that I always say that existence of bylaws in the website is insufficient, it is not working. Because my question is that who is that civil engineer who is saying that look, we can go for such kind of construction? Obviously these kind of constructions will be those by those who are not civil engineers then, and if that is the point, then the next question is very straightforward: how they are getting these constructions done. Simple. Obviously, for the state of Himachal, how to avoid soft story is a big question, because money is a big constraint. You need to construct in this, so you will be finding soft story unless and until you go again put up so much again amount here and then put up the walls. Although this enclosed area may not be used by that particular building owner. Whether such constructions can be avoided oblique be asked to carry out construction as per codal provisions means uh, here that's what, whether the such construction can be avoided and be asked to carry is, that's what the point was, that it's very difficult to avoid such kind of stuff story unless and until the authorities itself start saying that no, you will have to invest the money by reducing your non-structural component cost and so on. When I talk about such kind of constructions where I see a very less number of columns here, and then I don't know, I find lot of columns on the top here. So building outside the corporation limits might be rarely designed, because either these particular columns were too wide or too thin and so on. So they were just constructed based on the appropriateness wherever required. In the case of hilly regions, the major issue is that of the sliding zone. But the unfortunate part is that we have a habit of saving money by avoiding slope independent construction. And this is what you will find in many of the construction along the roads, that the retaining wall, which should have been an independent one, that was clubbed together with the construction, and then when there was a sliding, that affected even the building. So this particular picture is a symbolic or a sample for most of the failures that you find across the slope. Although there are many issues that along the slope it just moves down, but then in some cases as well it puts up the cracks in the buildings as well. Again, my only point will be that since these are the buildings which are outside the corporation limit, and design will always be questionable. Now, this is a government school. So, incorrect slab leading to economic loss. I stopped nearby and I asked this particular person that what are you doing? So he says that look, we are laying up this particular slab. So my question was that why are you breaking the slab and then laying new? He said that look, we earlier has put up the slab, but unfortunately this was leaking. So what we did was that we had put up another 3 inches of concrete so as to stop the leakage, but it was still leaking. And then we decided that we'll break this top portion, the slab, and then we will do the recasting of the slab. The points are, this is a school with the public money. The junior engineers, since I have taken up their trainings, the junior engineers, they are also stressed up with more than 200 schools under one engineer. Along with him, he has a mason who doesn't know what is a crank, what is negative reinforcement. So they do the construction with a normal steel flat without any negative steel, means putting up the cranks. That particular slab leaks up. So he puts another government money and then puts up this. And I asked him that how much is the life of this. So he said that well, the slab was constructed something around 10 years back. So it means that you are basically going on breaking these particular slabs within 10 years. So that is what the problem is, that incorrect slab leading to the economic loss means the inappropriate practices due to ignorance oblique incomplete knowledge. Requirement is continuous capacity building of supervisor, masons and the bar benders. The point is that how many books do we have to say that we require negative steel in the slab? then how many students are coming out with such kind of information? And still you will find a number of such kind of cases where you do not have the right practice into the picture. So this is the reason that the questions are basically to talk about implementation in the society of those correct practices rather than only running after advanced analysis and so on. RCC construction, vertical irregularity. Well, I have a slab construction here, clubbed with those retaining wall. Note of the good part in this was that there was a gap, which is, but then such kind of areas do end up being a very damp places in Himachal, what I've seen. But then when you construct similar things, so obviously you get vertical irregularity and unavoidable situation. Such kind of construction again with the soft stories. Again, another building with a soft story due to owner's planning and restriction at the owner. So requirement is restriction at the owner. And means the point was that this man said that look, I am going to remain only here. So let me put up only up to this. Then the question is that leave that steel here. Why? Then once you have the money, then you only when you require it. Sorry, then only you construct it instead of moving up for those complete construction with frames and then with only the infill here. Uh, in the case of again hilly states, the major issue is getting an appropriate site for construction. So the particular slide talks about whether the site condition forced the owners to adopt non-codal compliant construction. Means I didn't have the space, so I constructed these columns with obviously not as per the codal provision. But then my requirement of space was more, so I went for out of plane uh, floating walls. And then, so in all the cases, floating walls with such thin columns will obviously lead to a structure which is not as per the codal provision. And then this is on the right side, the similar situation is there. I need to maybe give an offset from the road that this much from here only you can carry out the construction. But as I move to the first floor, I'm free and I move for such kind of floating walls. Now let us come to the masonry structures. What I showed you earlier was a kind of a scenario what you find in the hill state. And then let us talk about some solutions that when I talk about masonry construction, you do not require any soil testing. You do not require any calculations. The decisions are on the spot. Means when I'm there, I can tell that look, this is the steel that you have to put. This is the bands that you have to put. You talk about sill band, you talk about lintel bands, then the roof band or the floor band, you talk about some steel in the corners. That's it. But the unfortunate part is that because of the construction aspect, that it is much more maybe easier to do very fast construction. You are going for RCC construction without times. And then this is the steel that you will require at the corners, then the beam, and then on the doors and the windows, you require two steel such that the cracks do not develop from the corners. And then these are those particular two bars with the stirrups. That is the typical details that are required for any masonry construction, reducing the cost of steel for the foundation, no steel for such a huge designs for the columns, beams, and it is just that in the case of hill state, transportation and working with smaller diameter reinforcements is much easier than with those uh, bars with a higher diameter. So when I was doing my study there, then at that particular time, these are the four things which I noticed, saying that look, you require only four things, that is vertical steel, horizontal steel, opening to the wall, and the wall thickness. With these parameters, you can actually go in for a very good masonry construction design. So this was the state of Himachal Pradesh, where I could find that this is the zone 5 and then these are the zone 4 areas. So I started saying to the state of Himachal Pradesh that look, if you say that instead of that line which is imaginary, because what I used to say is, first of all, I do not see an RCC construction in an appropriate manner. Masonry construction, forget it. Then, and above that, I have an imaginary line where if I'm standing here or here, I do not know, because who has the BMTPC cat vulnerability cat loss of 5,000 rupees with such a detail saying that you are here or here, and then I can say that look, I'm in zone 5 or zone 4. So I started saying that look, talk about the districts as zone 4 and zone 5, and let those particular lines be for those particular big structures, maybe for bridges, maybe for those buildings which are worth in crores, and do not impose such kind of an imaginary lines for the normal residential constructions which may be of 2 or 3 stories. So then if I say that, then I what I did was that I took up these districts as zone 4 and these as zone 5, such that these are zone 5 districts will anyhow have all those particular buildings constructed as per zone 5, and these particular zone 4 the important buildings will be constructed as per zone 5. And then these were the values which is already there in the code. They were actually grouped such that I impose this particular chakri and then I can revolve it. So even the app was made, and even this has been physically distributed a lot in the state of Himachal Pradesh. So my only point was that I tried to convert the codal provision into a form which is which is more easily understood by those particular people who have not been able to get the formal knowledge, so that you can use those things. Okay, once you go to this particular website of state disaster management, this is where basically the guideline for safe construction, these particular ICs have been kept, and one can download it from there. Coming up to the confined masonry, up to 2016, unless this NBC National Building Code came up with confined masonry, even I used to say that look, I could not understand because this is not a correct way of constructing the walls before putting up the beams. But the moment they came up and with this particular guideline saying that look, if you have a zone 4 and zone 5, then for 3-story use only up to 10 diameter, for 12 go for 4-story, this is the tie column, for tie beam you have to go for 10 diameter. So then one of the engineers again, since for those public works department or those executive engineers, they are not in a habit of using such thin beams reinforcement. They are only in the habit of using 20 25 diameters. So for them it is basically a surprise when we talk about such a smaller diameter. I've been interacting with Professor Chandan Ghosh of NIDM, and look, that is the kind of a scenario I just wanted to show, that it's beyond engineers' imagination that a mere 2-story building in one of the newest state capital has to have 25 diameter top bar like shown in the picture. So this is a 2-story building, and here you have a 25 diameter bar. When we talk about analysis design of RCC construction, we never say that go for 25 diameter. It's only we say that do an appropriate analysis design so that you get an optimum uh, design design components rather than going for unimaginable components. So Mr. Dhirek Momik, he writes for almost public small building mysteries are the engineers. Well, I can understand that. And I wrote that one of the known in Hamirpur had used 32 bars. Someday we might be asked to file such things in the court. So that's what the issue is present in the society, that those, I do not know which department will actually going to take up such kind of responsibility of providing the appropriate resource persons to a owner such that he can do get the construction done appropriately. Otherwise the problem is we have the websites, and then in the websites it is told to the owner that you go and search that who will be the right person to guide you. These are some of the initiatives that were taken up. Now coming from the theoretical aspect to the practice, that it was for when we were showing them this particular 2 bar bands with the C rings. So all those particular masons were saying that this is for the first time that we are seeing. And my trainings were between 2018 or something like this, maybe 17. So you can just think that these codes were out from the BMTP, from the BIS in 1993, and so it is more than 25 years or around 25 years that still such dissemination has not taken up appropriately. So this was the masonry construction with the single corner steel, and then this is the 2 bar reinforcement for the windows oblique the doors. Now here this is another, this was basically for the confined masonry. When I start talking about comparison between the confined masonry and RCC with the infill, then confined masonry would be acceptable if you have an interlocking of the bricks with the reinforcement. But RCC not acceptable if not designed. So if you are having such buildings which looks RCC and but it has not been designed, it is not acceptable, but then confined it will be. So confined masonry is an evolution over RCC being practiced extensively for saving money, oblique the time, because in this particular case, the saving of money is that on the two sides you do not have to put up the shuttering plates, because the wall itself acts as a barrier so that the concrete doesn't flow out. Appears to be RCC, thus giving psychological safety without analysis, now recognized by BIS in SP 7 2016. So maybe that if somebody goes for these things, then obviously it is acceptable. So you have a very fine difference between the confined masonry and RCC integrated with masonry and not integrated with masonry. And the requirement is that the masons oblique the owners will have to understand the difference to the sensitization programs, that look, this is what is confined masonry and this is a masonry circuit. I took up the project in 2012, something around 9 years back, with the Himachal Pradesh State Disaster Management Authority, to tell them that look, this is the kind of structures that you have, although they knew it, but the documentation was a major requirement. And so these particular pictures reflect that that was for the district of Hamirpur, that you will find that all these construction shapes are totally different, but all these particular construction lack the bands, they lack all those vertical steel. It is just that the putting of the brick blocks together with a roof, and then you have a house construction. The major points are you don't talk about any bands, you don't talk about any vertical steel. When you talk about non-engineered construction, so you move from this kind of a pattern where you have a pointing done with a very good quality of bricks, to the bricks which are plastered, means class B, and then you move for such kind of constructions where you also have a tachi divari, but then Such is the typical construction in the state of in the city Simla, and then you have the random level. So although these particular code exist of IS 4326, earlier it was in 1993, now revised in 2013, or 13827 or 828, but these codal provisions are beyond common man's understanding, and so the society has moved as per its own understanding of the requirement. I always say that there are two different departments working. One is the public works department and other is the private works department. When we were training the masons said that although whenever we talk about anything which is good, the owner thinks that he wants to make money. And so they requested that you come out with some kind of material for sensitization of the owners, such that when they see your material, maybe they will rely upon you, saying that whatever you are saying is correct. So then we came out with this aspect that look, if you are constructing anything which is without bands, not good; with band, it's good; without bracings, not good; with bracing, it is good. Then you have a vertical irregularity, should have a separate wall. If you are having the building in setback, then go for a separate seismic expansion joint. If you have a building with the staircase, keep the staircase separated so that this staircase which generates a stiffness along the wall, thus making it torsionally unstable. Then in this particular case, you will have this building, much safer than this. Then in this particular case, again, what I talked earlier, that you should have at least a 2 feet of gap, because what the codal provision talks about for seismic zone 5 is something around 560 mm. I converted all these things in the form of feet and inches such that it is easier to understand. So I said that look, go for at least 2 feet of space from the inner side of the walls or between the two openings and so on. In the case of buildings, especially the schools, most common issue is with respect to the plan irregularity. Nobody likes to provide extra joint or this seismic joint. When you have a L-shaped building, they will go for integrated one. This is the most common irregularity you will find in all these buildings. In 2008, the education department approached us saying that in Sarviksha Abhiyan, they have a mandate of getting all the material tested. That's why they approached us. Now, in this case, what has happened was that the total cost, whatever was coming out, the education department was asking us to, go for only a little bit more of 50% of that projected cost. And so that could not be done. But the major point that was raised was that instead of going for the material testing, why don't you involve us for the aspects of structural audit or to control the construction? And it was said that, well, that is not included in the policy. So this is the reason that this particular brochure was again developed, because it raises the question of issue of policy versus implementation. And the major flaw that was there in the construction of all the schools under Sarv Shiksha Abhiyan was that the construction practice was totally neglected. And this is the reason that this leaflet that was for Himachal Pradesh के प्रधानाचार्य के लिए सुरक्षित विद्यालय निर्माण कार्य महानिदेशिका, What was the system of construction of those or the expansion of the schools? That you will have something called as SMCs, that is School Management Committee. The School Management Committee, without having engineer, are authorized to go for construction along with those parents and even the pradhan who are not engineer or even the diploma holder, and they were authorized to go for construction just like as if they are building their own houses. And this is the reason that these all those particular buildings were got surveyed. The government senior secondary school 90 were surveyed, and then these were all those problems which were highlighted at that particular level. तो जो दिखता है वो होता नहीं है और जो होता है वो दिखता नहीं है. So basically, although you might be seeing all those schools, 15,000 schools in Himachal, or maybe those thousands of schools in other states, and, but the major issue was with respect to policy, and this is the reason that the school safety is now in the Supreme Court, because the issue is that most of the buildings have been flawed because the construction practice was totally neglected, and that is what I've seen in the society, that construction practice is the major component which is neglected. We let us now talk about, when I talk about non-engineered construction theory to practice, because these are the aspects which we normally neglect. That 90-degree stirrups, we in the case of earthquake prone areas, we say that you should go for 135-degree and 90-degree stirrup should be avoided. But the question is that I've been putting up sab kuch sasta, sabse sasta. We want the things to get done at the cheapest cost without even extra input to the money, and we expect that the quality should also be good. But for the participants, let me tell you, 135-degree stirrups, the extra cost involved is 25%. Why? Because the mason or the bar mender faces the problem of inserting these particular stirrups with the 135-degree stirrup. So the point is, are we ready to pay that extra? If we are not ready to pay extra, then he is going to give you this. Where is the problem? Second point. Now let us talk about with respect to sand. Extra cost, washed sand. This much is this was might be an earlier figure. Maybe that figure might have increased. But then, if we are going for a muddy sand, and if you are going for a very good sand, then there is a difference, and that particular difference need to be paid. Unless and until you pay for the quality, you will not get the quality. Another major issue what has been seen in the society is that we move by what others are saying rather than getting into the depth of the things. If you refer to the BIS website, or I'm opening up this document bis.org.info, yes, then in this case, this particular document, are you a victim of fake ISI marked product and you allow that to happen to you again and again? So all this, with all these sections and so on, let us get to the point directly, saying that look, this is the standard mark of ISI, where you have a code written over it, and you know, construction manufacturing license number is there, which is a 70. And the point is that you find all these kind of you know, ISI marks are there in most of the hardware, and even to an extent of these reinforcement bars. Here, if you can see it, this is the IS mark is there. You cannot, it is very difficult for you to put up this code number and the manufacturing license onto this particular bar. So this is the reason that good manufacturing companies, they do not put on these bars, but instead you will not find in a quality of those products, those companies which are selling quality products, you will not find these ISI marks there. You will find it only on the wrappers. Reason? Reason is that you get all those particular material manufactured, oblique extruded, take a sample in the standard with the standard procedure, and then get it tested. Simple. And if it is okay, you move out with that quality product. And so where does their marks are there? The marks are there on the wrappers, not on the products. When I talk about the construction, then even I start talking about that most of the time when we teach the BTech students, we just tell them that look, this is an RCC construction about the bricks and so on. We hardly talk about these AEC blocks, that is autoclave aerated blocks. Use those things. No doubt there are issues with this. Cracks get appeared up if the construction is not appropriate and so on. So in that particular situation, uh, use of light autoclave aerated blocks to reduce the building cost, increase the life safety, reduce thermal load of the building during the winters. The issues are owners are unaware of, fear of security is there, public sensitization, thermal efficiency. Those things are the issues with about which the owners need to be sensitized. Means sensitization means thermal efficiency. This particular thermal conductivity of autoclave blocks is not much. It is much lighter in weight. So the requirement is awareness programs and appropriate applications. I started the talk with the traditional construction practices, talking about this Kathpuni where you require the wood, the Daji Diwari. And another style is this Khatra style, which is there in the Chamba area, where you have those particular columns in this particular pattern, and then you have a combination of these Kathpuni. But unfortunately, if you just search out traditional earthquake resistant construction have proven themselves but prone to fire. So if you just write such kind of Google out these things, so you will find lot of fire incidences. So such kind of initiatives are required. BIS doesn't recognize presently. Can the state take initiative? We will be much closer to BIS. You require fire resistant technologies and so on. So although technologies, what I have been emphasizing upon that although the technologies do exist, but we require such kind of sensitization programs. We require sensitization programs such that, and then getting in touch with the grassroots level people, and then so that these technologies get. When I talk about all those particular things, that is the non-engineered constructions are there, and as I talk about theory to practice. So when I say that I have a masonry construction, but then splint and bandit technique, brick masonry, dress stone masonries are there. These are the things which you will find, especially in the hilly states. So the issues are the random rubble wall to be jacketed, and the requirement is understanding application procedure as per this IS 13935. And then there are handbooks are available, but the schedule of rate is still awaited. Oblique can initiative be taken. When I talk about RCC construction retrofitting, then in this particular case, you only give a knowledge factor of 1. And when you move down this particular serial number, you will find that Documentation as in serial number one, but no testing of material. Documentation one, no testing of material, that is originally specified value of material. You will hardly find that such things are there. So when you multiply this knowledge factor, you will find that most of the buildings are unsafe. So here the issue is that the states do not have the data, and the requirement is strengthen of which reduce the dead load, and then only you will be able to reduce the risk. These were some of the works that were carried out from 2011 onwards. Government Senior Secondary School 2 this was in 2016. So the crux is engineers oblique architects are not involved in all construction. BIS code are not a common man's manual. IEC is not available at the grassroots level to the extent required. In the rural areas, because that is where the connect of non-engineered construction is, common man is anyway making its own design layout, that is, he's playing an architect role. Structural design is mason dependent, he's playing an engineer's role. Supervision, well, Mason says that look, it's not necessary. I am the master. I can do anything. And then when you talk about safety, it is at your own risk. Why? Because the moment construction is over, uh, I have never seen, or maybe in some cases this might be there, that will you be able to find those particular masons after 5 years, 10 years, whatever? Because they might have moved on. So go for masonry, oblique confined masonry, choose appropriate masons, oblique contractors. That is what is the major requirement. So we'll have some particular discussion on this. It all depends how we are oblique want to handle the things using more complicated solutions and be workable, and then talk about efficient implementation. When I say this, what I want to say that when I saw talk about complicated solutions means when I talk about RCC construction for rural areas, and then going for analysis and design, and then talking about that look, those analysis and design should be perfect, or let us be innovative and be simple means talk about those confined masonries, and the masonry some changes could be done and still be workable. Means here what I want to talk about that I have some coconut water, but then I'm using a polythene. But when I went to a vendor, one another vendor, gave me this. So this is what I'm trying to say, that you need to be simple and innovative, and then it will be working. So with this, I would now request, in case there could be some points for discussion. Uh, yes, Dr. Mahesh. Yes, any participant in case he would like to discuss. Uh, share the presentation with us. Actually, the major issue was that these particular photographs which has been clicked in the state of Himachal Pradesh are the private owners photographs. So the major point is that being from with respect to the copyright issues, since we normally do not take the permissions of these particular buildings, so this is the reason that sharing their photographs becomes a copyright issue. Because as Dr. Mahesh has already told, that I'm presently now in Entrepreneurship Development and Industry Coordination Department. So basically talking about IPR, intellectual property rights, and patents and other things, we talk a lot. So it is in this context that some of the materials which you require are already there in these particular websites. So if I were to again share my screen, and if you go to this website of HPSDMA, so here you have the citizen corner, and then you can go to for this guidelines for safe construction. Even I will go for, so here you can see all this mason's guide, owner's guide, typical, all those things are already given here. If I go for, if you want a collection of all this IC material, then you can just check for matrix of IC NDMA, National Disaster Management Authority. So NDMA has come out. We had the meeting in the NDMA office in New Delhi, and this is the matrix of PDF material with all those links. So one can go for all those particular material links here. You can see here all those particular matrices there of various ICs, and this was developed basically for different, for artisans. This was categorized for artisans, for children and student, for common man, for engineers, for homeowners, and so on. So that is what was done in that particular meeting. Then for policymakers, this was the whole matrix of IC material is there. Then even one can get all these particular, one can, you can just ask me that where a particular material is there, and then that can be shared. Such as the cheaper way to repair cracks like yield line pattern in the slab. Okay. When I talk about repairing the cracks uh, in the yield line pattern in the slab, then the CPWD has, although I had not been prepared for that directly, but then you just CPWD publications. Why I'm talking about with respect to CPWD publication, because I can anyhow talk with respect to uh, the non-CPWD as well as with respect to CPWD. So here you can see this is the maintenance manuals are there, and then this is the schedule of rates are there. So why I'm talking about this is because in this schedule of rates for new and innovative technologies, there are two directions. Either you are talking about repairing the cracks of government buildings or the non-government buildings. If you are talking about repairing the cracks of non-government buildings, that is the private owners, then you are free to uh, go for any of the companies like Sika, Cisco, or uh, that is Dr. Fixit is there, BSF is there, and so on. I'm showing you one of the projects that was recently completed, that is of a temple in Nurpur, that is in Kangra district. This is rehabilitation of Brijraj Swami temple at Nurpur, Kangra. Now, what this was, that this was some particular buildings with lot of cracks and so on. And in this particular case, what was done was putting up the scaffoldings, and then so here you can see all this. I don't know what this figures are not getting shown. I'm just now opening up the Word document. So here you have all those scaffoldings was put up, and then these all these cracks were filled up with this, and then these were the chemicals used, and then carbon fiber wrapping was done, and then finally we came out with such kind of output is there. So when we talk about repairing the cracks, then this companies are there. Osrock, ESF, Dr. Fixit. Basically, these are the companies which are supplying the chemicals. They have their own specifications. They have their own, strengths of their chemicals. Like these particular Fisher is the, this is the, so if you want to do anchor bolting of this particular, reinforcement bars, so you require the fixing chemicals. So in this particular case, this is that particular chemical of Fisher. So what I'm trying to say here is that these particular companies have their own rates. They may not be in the schedule of rate of the SOR, that is the schedule of rate of these Delhi schedule of rate or HPPWD schedule of rate. So this is the reason that we need to differentiate between the two works. So if you question that how did we got it done, so then in those cases you get a special approvals done for the application of these chemicals. Like in this particular case, it was a very special structure. So for very special structures, you get all these things done. So that is how you approach a particular problem to get the work done. In this case, maybe if I don't know how much time it will take, but then this is, we can open up this document of innovative technologies, and here you will find uh, in the innovative technologies, or it is there. Let us see. I'm searching the crack here. So here it is not there in this case of crack, but then it will be there in this schedule of rate here. This is for electrical. This is in the 2000. Either it will be there in the volume number 1 or it is in the 2, because we used to refer these particular volumes for estimation of the work for the repairs and the rehabilitation. Okay, sorry, this is specification. This is specification. We should check up with the schedule of rate. Yes, this is the one. Here you can see acrylic polymer chemical for cracks. So the per rate, at least this is they have given. So the acrylic polymer chemical. So if any supplier is giving you a chemical which is acrylic polymer, then this is the approved rate. Now here the gypsum board partition again, well, then this is for gypsum board partition. Then let us now talk about the second one, if anything is there in this. Yes, here you can see providing and applying integral crystalline slurry of hydrophilic in nature, waterproofing, and then here seal healing or cracks up to a width of 0.5 millimeters. So per square meter, this is the approved cost. Now, then this is the second one, providing and applying integral crystalline of hydrophilic in nature for waterproofing treatment. This is for waterproofing treatment. I'm coming for per meter. Yes, this is the one of what I was searching for. Providing and applying crystalline mortar by mixing ratio of 4.5 is to, that is crystalline mortar one part water for these cracks, and then this for sealing the cracks and faulty construction joint, rooted out, make U-shaped grooves, size this much, then primed area this, and so on. And so this is the rate, 525 rupees 70 paisa. This is that clause 22.25. You will always get it in the form of per meter only. Means if you want to that. So that was the main that could be looked into. That is 22.25. This one. The only point here will be that the different chemical suppliers supply the chemicals of different nature. So one has to see that how that chemical of different nature fits into this SOR, or one has to really get the approval. Otherwise, one is very well free for different private works. In case any other next question. names of the manuals. Please
Yes,
answer.
Dr. Hemant, sorry, I think you were saying something in between. I forgot to reply.
No,
Yeah,
Mr.
please tell me. Yeah,
Mr. Sridhar is asking for to unmute him.
sure. Wait a second.
Yes,
Wait a
sir. Yes,
second.
done. Yes,
Yeah,
done,
yeah,
sir. Yes, done.
yeah.
Thank you, sir. Thank you, much. Hello, sir. Good afternoon, sir.
Yeah, good afternoon.
Thank you, sir, for very much informative and an eye opener for every municipal authority, not only in Himachal Pradesh, everywhere in our country, and also for civil engineers who are simply blindly signing the documents. Maybe for the sake of maybe 50 rupees, 100 rupees, 200 rupees, 300 rupees given by the authorities just to approve the giving structural stability certificates and all. This is very informative, and two, you are actually should not be an alone in actually fighting this maybe say calamity. Everywhere it is there in our country, wherein it is not so easy fighting with the authorities and fighting with the system. Thank you so much for the work you are doing in the interest of the nation and interest of the life of people of our nation, sir. Thank you so much. Then my question, come to my questions, sir. Regarding cracks, usually in this type of masonry structures or else non-engineered or semi-engineered structures, as you have shown columns with the walls and the sill and the soffit of the beam resting, taking the support of soffit of, top of the wall as the support for beams and all. In such type of construction, sir, we are most of the time we are getting cracks. In parapets, we will be getting a cracks at the center, vertical crack, or else when we are constructing a compound wall, which may be of a length more than 50 feet or maybe a 60 feet or whatever it is, at the center we will be getting a vertical wide crack. And also in openings, in window opening, actually you have pointed out, in window openings at the corners we will be having the diagonal cracks. And most of the cracks what we get in such type of construction, is that addressed in any of the schedules, or else why it comes and what is the remedy, sir? This is one question of mine, sir.
Okay. Yes. Especially if you, that's what, this is the reason that I have, made up that particular, this one from policy versus implementation, and in this case. So one thing I just wanted to ask you, Mr. Sridhar, that first
Yes,
of all, coming up to one points question wise.
Yes.
One is that one was you were talking about the diagonal cracks around the corner of the opening.
Opening, window openings, most
Okay.
often, or door top.
Oh, door top. Okay. My question is that is it that you are because the window or the door window is having 4 openings. One is 2 on the top and 2 on the bottom. Are you talking about crack on the top, that is lintel?
No, not at the lintel, below, at the sill, sir. Sill, a crack starting from the corner going towards the floor in the diagonal direction.
Okay, in the diagonal direction, that is. So in that particular case, what is happening is that when you have such thing, it is only because of the differential settlement of that particular opening. What is happening is that when you have an opening, the load is less. On the other side, that you have a more load, and this is the reason that you have a differential settlement in the bottom of that particular opening.
Yes.
For those who would like to, go through these kind of cracks and other aspects, there is a book I have to exactly remember, that is again written by the CPWD only, some Mr. Basu Roy, Nabi Publications. Let me just write maintenance. So there is, there is a book by, I think this is examination. Yes, maybe this is the one. Jan Book Agencies.
Yes.
These are the books: Practical Handbook of Building Maintenance, Practical Management at Civil Engineering Projects, and this is the one, could be this one. So
Yes, sir.
one is by, okay, this is by M.K. Gupta. This is another person who had written, and
Okay.
being a ready reckoner for day-to-day management and technical solution of maintenance problem in the building. So
Okay.
one can refer to this particular book of, maintenance.
MK Gupta. Okay, sir.
M.K. Gupta. Yes.
Thank you. Yes, sir.
And as I said that when you have a corner anywhere, wherever you have a crack in the corner, it means it has only and only to do with the differential settlement. So
Okay.
on the sides, you have a more load, and on, so if you say that how do I avoid it, it is
Yes.
only because one has not given a proper plinth level or plinth band there, so that the differential settlement would have been arrested.
Okay.
So one
But
is,
surcharge will not be taken out now. So even if we give a band, surcharge will be there on the sill, on the sides. Means the load, differential load will be there.
the band is going to distribute that particular load. This is the reason that we emphasize more upon the bands.
Okay.
If the band will be there, that band is going to distribute the load, and you will have a more uniformity all across that level, and this is the reason that differential settlement will get arrested.
Okay.
Point number two, your window opening is going to come above that particular band, so this is the reason the crack is not going to move down at all, because crack is not going to cross that band at all. It cannot.
Initiated. Okay. Will not be initiated.
Yes,
Okay.
the band will not allow to initiate the crack itself.
Yeah. Yes, sir. Yes, sir. Got it.
Second point, in the case of openings, the cracks on the top do not appear if it is appearing, and if you do not want it to appear, then proper this time should be given for the shuttering of the lintel. The reason is, what we do is we put up the lintel beam, and just within 2 days or 3 days we say that, well, it has set, and now let us remove the props. If you remove the prop earlier, then the cracks will develop from the corners of the openings on the top. It is only because of early removal of the shutterings or the props.
Yes, sir. Yes, sir.
So that's what it has to do more with the construction practice rather than with respect to the design aspects.
Yes. In case of compound wall, sir, in case of maybe stone masonry compound wall, or else solid block compound wall, or else brick compound wall, when the wall length is more, exactly at the center, if it's 100 feet, exactly at the 50 feet. If it is 50 feet, maybe exactly at the 25 feet. We will be getting a vertical crack most of the time. Is it for contraction and expansion, this one issue, or else we have to give a break there at every
That's
30
what
feet?
the breaks are required. Otherwise, it has to do more with respect to the slenderness ratio.
Yeah.
Especially not in the case of, basically we cannot directly talk about in this case, but especially in the case of earthquake, they say that whatever is your thickness of the wall multiplied by 35 times, that should be the maximum length of the wall.
Okay.
So if suppose my wall thickness is only of 9 inches, I multiplied by 35, and so maximum what they have given is 8 meters, and 8 meters is something around 25 feet.
Yes.
But
Yes.
but my again question will be that if you have constructed something of 25 feet, did you got any crack in the 12 feet? So if it is not there, it means that the maximum length of 25 feet, then try to give a gap.
Okay, sir. Thank you, sir. Just one more question, sir. One more question or my query is in Himachal region, you have shown many buildings or else the plots are having level variations. To just make up to that level variation, they will be having 2-3 basements, wherein only columns and a slab will be there. and they are, because they are in fifth and 4 and 5 seismic zones, definitely they are going to fall because of this substory effects. Wherein what I mean, my actually thinking is, if we go with this RC bracings, wherein mass will also be less, there is no need to construct a wall and all, so mass will be less. If you go with the bracing of alternate spans, if you go for cross bracings, will that suffice us so that cost will also be less? Can we avoid this vibrations due to earthquakes because it is in 4 and 5 zone? Just I am thought of actually putting that in.
Are you talking about government or private?
Private build. You have shown so many private buildings wherein so many, to make up to the level of the road, they are having 2-3 stories just to make it up, and they don't want to invest also because that's not used also. Where so many buildings were, I've seen, you have shown so many buildings. If some shaking is there, minor also, I don't think they are going to stand it up because of this substory effect. Wherein bracings may be used there in alternate spans.
Sir, that's what I'm trying to say. They are not ready to construct the building in a normal way as per our codal provision. Talking about bracings to them will be a kind of a bouncer to them. Very frankly. That's what I was trying to say. They do not want to go for quality construction with proper beams that is fully casted. Some cases I clearly showed you masonry columns, and what is there along these roads, whatever this construction is. There is another part of the story is that we do not know who are the owners, because when you go these are of hotels or small time stop by constructions are there. And 2-3 years back there was a failure of 4-story building where army people have stayed there, but stopped there for some refreshment and so on, and there was a collapse. So the one point what I'm trying to say, that whatever the normal construction they are doing, that itself is not proper. When we talk about these bracing aspects and so on, we really need to see that who are the masons who will be able to handle this thing. This is the reason that I first time only I said, are you talking about government or private? Because in case of government, we can very well talk to the executive engineer because they are at our same pace. But in the case of private, that is a problem. That there is a owner, he doesn't want to talk about, he himself considers himself an engineer. That's what
but construction is bound by the municipal authorities, sir.
Municipal, that's what my biggest issue is. Municipal corporation has a limit, and my most of photographs were beyond municipal boundaries, and that is where the problem is. And the problem within municipal boundary is also there, because I asked, because there you will have only one junior engineer in Shimla or two junior engineers, and you cannot expect them to move around the buildings which are under construction and see that the construction is happening properly. They are mostly fighting the litigations there in those cities.
Okay, thank you. Thank you for answering this question. I think that was the question. Yeah.
One more thing, Mr. Sridhar asked for some particular manuals which I could not follow. Please repeat the name of this manual, which manual I could not follow.
Mr. Sridhar, you are there?
Okay, Dr. Madhu had said, sorry, please repeat the name of the manual. Which manual? It's all the Delhi schedule of rates is that DSR. You can just Google out CPWD publications. CPWD publications. If you just write CPWD publication, you will get the first link, and then in that first link you will have all that material that is related to Delhi schedule of rates, specifications, everything, maintenance manuals, everything is there. You just have to, or I just put down directly the, I'll just put down the link itself. This is that link.
Yeah. Thank you, sir. Thank you also for sharing the link. I think your presentation was one of the most, I must say, the most helpful for all of us, especially for those engineers or academicians who are working in the hilly regions like me. And all, whatever you discussed, we see it every day in the field, adjacent to my home. And yeah, so this lecture was one of the most relevant lectures in this series of lectures on disaster resilient infrastructure. So I thank you once again, sir, for taking out time for this lecture, and look forward for collaboration, because that is something that is very much required for from my side also, where we can together with along with NITA Chandigarh work in coming up with some proposal guidelines regarding this sort of disaster resilient infrastructure, how we can achieve it. And especially, very much if you see Shimla, which is every day so much construction taking place, although the Green Tribune has been very much heavy on the state, but still construction activities are still going up, right? And so I think somewhere we have to draw the line, and engineers, academicians like you have to come up in the field also, on the field also, and help us all. So with these words, I thank you again. Thank you very much, sir, for accepting the invitation and delivering a wonderful lecture.
Thank you.
Thank you, sir.
Thank you also for giving me the opportunity to share again my all those particular experience in the course.
Yeah, yeah. Okay, sir. Thank you. Thank you. You may, yeah, yeah. So, dear participants, our next lecture will start by, I think, 3:30, right? I think that's the time. So, Professor Barnstu will be joining us from 3:15, I think. Okay, so we can take 5-10 minutes of a break, so that Professor Barnstu can join us from NIT Hamirpur and cover the topic regarding landslide disaster mitigation. So we'll have 5 or 10 minutes break. Then we'll start at 3:23. Thank you. You all are requested not to leave the meeting for the sake of attendance and uninterrupted. We can have an uninterrupted session with all of you. With these words, thank you, and let us join back at 3:23 p.m. Thank you. I think Professor Barnstu has already joined. So, sir, will start our next lecture at 3:23.
Yeah, sure. I'm there. Yeah.
Yeah, yeah. Thank you, sir. Thank you.
Okay.
Professor Banstu, can you hear me? Yeah, hi sir. Yeah, good afternoon to all of you, and especially to Professor Banstu. I welcome Professor Banstu to the last lecture of today. That will be on landslide disaster mitigation. So it's my privilege to welcome Professor Banstu formally, and sir is from NIT Hamirpur. I have his brief CV with me, so let me go into it. So Professor Banstu is presently working as associate professor at NIT Hamirpur in the Department of Civil Engineering. His research interests are engineering geology, natural disasters, and global warming. Professor Banstu has published research papers in various fields, especially in engineering geology, natural disasters, global warming. With these words, I welcome Professor Banstu to deliver his lecture. Thank you, sir. On behalf of organizing committee, I am thankful to you for accepting this invitation, and be great to listen to you on the topic landslide disaster mitigation, because we are in Himalayan region. And every day, right now also, you might have gone through the news that a sad incident has taken place in Kinnaur a few minutes back because of debris slide, where I think few people have also died. So with these words, this example, which I'm narrating right now, also highlights how much relevant the topic of landslide disaster mitigation is. So to discuss this, to deliver a lecture over this, to brief us about his experiences in this field, I hand over to Dr. Banstu to take the dais and go ahead with his presentation. Thank you, sir.
Thank you, Dr. Mahesh. Good afternoon, everyone. I am thankful to Dr. Mahesh to give me an opportunity to interact with the participants of this faculty development program. Before I proceed, I would like to share the screen, what I'm going to present today. So let me know if it is visible to everyone.
Yes, sir, it's perfectly visible.
It is visible. Okay,
yeah.
Thank you so much. Now, as my topic goes like landslide disaster mitigation, as Dr. Mahesh rightly pointed out right now, that a lot have been happening in the past few days, right from when this rainy season started, particularly in Himachal Pradesh. A lot of accidents have occurred, and so many precious lives have they lost those lives. Not only this year, it is happening every year. So, what can be done? To I'll be sharing some pictures with you regarding these disasters in due course of time. So let's go by what basically the landslide is all about. So we are only talking about landslide disaster. I hope all the participants, they are from civil engineering background, or maybe they are from other geology background also, and they must have come across this term, that is landslide and disaster. So disaster can be of many types. So disaster is a term used for some accident which is on a large scale. So large scale means not only that it is happening over the whole state, but large scale, I mean to say, is when there is complete destruction of a particular structure, or maybe some precious lives are lost. So, like we have this disaster of pandemic. This also disaster which it is occurring across the world. So, likewise, a small portion of the happening natural accidents, which we call as landslide. So, what landslide is all about? Though there are many definitions about landslide. To a layman, landslide is something when a portion of landslide is known, so that we call as a landslide. So this is a mass movement of material, such as it can be composed of rock, earth, or debris down a slope, because it is moving under the influence of gravity. So they can happen suddenly, or more slowly, or over a period of time. So they can be classified accordingly. When the force of gravity acting on a slope exceeds the resisting force of a slope, the slope will fail and landslide occur. So whenever we come across these videos on social media, or we see it on news, so recently there was a landslide in Sirmaur area of Himachal Pradesh. So what we could see is there was slight movement of maybe some small debris down the slope, and then after a few seconds or few minutes, the whole road went down. So what makes it to resist it at a place? That is what is the resisting force, or a frictional force, which we name it as. So when this the driving force exceeds this resisting force, or the frictional force, then the slide is going to happen, and we call it a failed slope. So before I come on to the mitigation measures, I would like to throw some light on background of landslide. I mean, until unless we know how it is happening, why it is happening, I don't think like we will be able to take a remedy for it. So it is very important to know the genesis of it. What actually makes a land to slide? What are the reasons? So accordingly, we can mitigate this disaster. A sketch showing here. So this is this has been taken from a PowerPoint presentation already on the internet. So this is a sketch of slump earth flow, showing commonly used nomenclature for labeling the parts of a landslide. So to a geologist or to a civil engineer, the landslide is a very complex, what do you call it, a phenomena. Complex in the sense like he tries to understand why this is happening and how we can really put it, keep it, or make it stable. So the main the parts of a landslide which we can see here are from crown to toe. So crown is a portion where we can see the remnant of the material which is still at place, but it is likely to come down, because we already see the cracks, they are appearing there, which subsequently will lead to the failure of this zone as well. Then is the material which has already come down, we call it head. Then we have the minor scarp on the sides, and then the surface of rupture along which this whole material is sliding down. Then the whole body, which is again sliding down. Then it is a toe from where it actually started. Now the toe, which was earlier here at this place, has gone down, is overflown to the downslope area. So these are, I hope you all are aware about all these terminologies used in a landslide. The classification with respect to depth of a slide. When we call a slide, maybe that's a surface slide only, then which is of course 1.5 meter depth. Then shallow slide 1.5 to 5 meter depth. Deep slide 5 to 20 meters depth, and very deep slide, which is more than 20-meter depth, which is happening, usually over a large area. Excuse me. Then, based upon the type of movements, the landslide can be again differentiated according to the type of movement. Type of movements are fall. So when we have a rock fall, as Dr. Mesh rightly said, just now mentioned a rock fall in Kinnaur area today itself. I think I also have a picture of it. I'll show it to you. And then recently we had a rock fall in Kinnaur area of Batseri, near Batseri in Sangla Valley, where I think 4 or 5 people lost their lives. And then there is a rock fall, which when the rock comes down suddenly, rolling down a slope, so hardly gets time to skip, because we are moving on a road and it comes down suddenly. And likewise, then if it is debris, which is predominantly coarse material, we call it debris, which is a mixture of soil and rock pieces, we call it debris. And then if it is predominantly fine material, which we call earth, that's again a fall. So fall can occur for rock, debris, as well as earth. The second type of movement is topple. Topple means when a material topples, the top of that body comes down first, then the base. So that we call as topple. So in case of bedrock, we call rock topple, debris, and earth likewise. Then next is slide. Now when things start sliding from its place rather than falling down. So it is of 2 type again. Movement is of 2 type: rotational and translational. If it is in case of rock, we call it rock slide, debris slide, and earth slide in case of fine material. And lateral spreads are there, where due to some fine material, maybe particularly clay, a kind of pressure is developed within the body, and it starts spreading. So rock spread, earth spread, and debris spread. The flows, that again is a mixture of all this material, rock, debris, or earth with the water. So it starts coming down. Of course, water reduces the frictional forces within the material, within the body, or with the base of it. So if we have a complex of all these, maybe at the same place we have rock fall or debris, and everything is happening in the same place, so we call it a complex type of movement. So if we see the next slide, which is a description of landslide features and dimensions. Example, the picture to your sketch to your left is we have which I described in the previous slide also. 1 is crown and 2 is the main scarp. Then we have head portion is this. Then we have upper part of the landslide. And number 4, that means this area is upper part of the landslide. 5 areas, the flanks, right or left flanks, because this landslide goes down. We have minus scarps on the left flank or right flank. And then main body of landslide, we have this the whole middle portion. 6, toe is the lowermost portion. Then toe of the rupture surface, that means where this slide actually started from. So that we call as toe of the rupture surface. Then we have secondary scarps. You can see the main head is there, then the secondary one is there. Then rupture surface, we have this whole length is the rupture surface along which this material has moved down. Then the displaced mass. So this whole body is called displaced mass because it has displaced from its main position. And then original slope surface. So this is the original slope surface, the dotted line prior to its coming down or stooping down or moving down. This was the earlier original slope surface. So if we want to measure the dimension of a landslide, so you can see here that is the maximum width B. Then the height is the H, and then total length is given by L, and then the length of the displaced mass is given by M. You can see here from where it has displaced this dotted line here to where it has actually reached. Then length of the rupture surface is L, so that is the original surface along which the rupture has taken place. Then L dash, M dash, S dash is the horizontal distances corresponding to L, M, and S. So they are given here. A is the accumulation zone. So see, if this is the original slope of this material, I mean, when along which it was earlier. So this area is accumulation zone because more material from this area has accumulated to this region here. So this we call as accumulation zone. E is the depletion zone because the material has is depleted from this zone E marked here. Thickness of the displaced mass is given by D. R is the maximum depth of rupture surface. So, which I said earlier, 0.5 meter, 1.5 to 5 meter, and 20 meter, and so on, more than 20 meter. So this is what is the basis for classification of landslide based upon its depth. So this is the maximum depth of the ruptured surface. So X is the angle of ruptured surface, that is with respect to, of course, the horizontal. So this is the angle of ruptured surface. So this it may vary from place to place depending upon the type of material as well as the slope of existing physiographic feature. So these are just to understand what rotational and translation slides look like. So we have rotational slides where we have the ruptured surface is you can see is curved as well, and in case of translational, that is almost a plane surface. The block slide and rock fall, I'll just go quickly through it because just to refresh your what you have done earlier. So rock fall, you can see the pieces of rock coming down the slope, and here block, the whole block is coming down. You can see along, of course, the slope of the surface, which in geology we call dip. Along the dip slope, the material is coming down, and then topple. Now you see, which I was trying to describe earlier. The head moves first, then comes the bottom down. So it is toppling material. You can see the rock is usually rock, and sometimes debris also topples. So that is a toppling of slide, and then toppling of land surface, and we have a debris flow due to mixture of rain as well as debris. So it flows in the form of slushy material. So that we call as a debris flow. And debris avalanche and earth flow. So we have debris avalanche. Avalanche, I hope you understand the word avalanche. When this slush material moves with the high velocity, we call it avalanche. And when it is moving with a slow velocity, we call it it is flowing. Then the creeping is another feature used for landslide. It's a kind of landslide only, but only thing is that it is moving at a very slow pace. So it can only be judged either by instrumentation or by observing the maybe the plantation or some other surface features like tilting of pole. You can see here because it is not tilting overnight, but over the period of time it is bending downwards. And then we can also see the trees which are bent at along their trunks. They are bent semi U shape, like not inverted J but opposite J. So that means the soil is creeping, but tree is trying to be upright. So hence we can see these. You see here, yeah, on the right you can see here. So this is how the creeping takes place slowly, and you can see the fence also bending downward. So this is again the pole. We can see the pole also here. So this movement, very slow one, is we call it as creeping maybe few centimeters per year. The velocity is very slow. And lateral spread. So it is almost not horizontal, but very at a very little angle, very little slope. So this material is spreading. This is on a bedrock. We have fine clay and soft clay, because as we know that clay absorbs a lot of water. So upon absorbing water, it swells, and as a result, it will start pushing the material downwards. So we call it as lateral spread. So these are the mixture of all these rapid mass movements, slide, slumping, flow, etc. You can see here the rock fall. So this is a type of rapid mass movement. Now the mass movement, and then we say rock slide, then we say debris flow, or we say slump, etc. So mass movement includes everything in it. So it may be the rock or debris or earth. So we call it rapid the mass movement. So another picture here of slump. You can see the detachment of the material which has slumped down. You can see another crack here which can also come down again. So this is a type of slide which is not it does not move too far, but has settled down as compared to the its original position. So that is what we call as slumping. Now this what are the factors for controlling the slope stability? Those slope stability is altogether a complete subject in itself. But when we are talking about the mitigation of landslides, so we will only take this to the place where you can say sometimes the risk is involved. Now, what do we say? Where do we apply the term risk here? Because risk is risk of landslide. It will be at places where we have some human structure, or maybe you have any infrastructure, maybe road or any project, or maybe fields, etc. So wherever risk is involved, we may go for slope stabilizing the material. So what do we see in the first instance? For example, the slope angle of material properties. So these you might have studied in your material practicals. So this the slope angle for fine sand is fine material is less than that of angular pebbles or coarser material. So this is called angle of repose. This is called angle of repose, means it is stabilized under natural conditions. So if we try to disturb this angle of repose, for example, this is 35 degree here. If we try to excavate it, make it steeper, maybe 40, then again it will settle down so as to make 35-degree angle again. So that is angle of repose for that is different for different type of materials. And it is not that the landslides are occurring only along steep slopes. They do occur along gentle slopes also. May not damage our infrastructure completely, but sometime will obstruct maybe the passage. So maybe small amount will come down along a steep slope, but in case of gentle slope, the whole mass will come down and maybe block the passage, or subsidence may sometime take place due to various reasons which we will discuss in due course. The another factor that control the stability is vegetation. So usually during due to forest fires, this vegetation is burnt, and as a result, the area or the topsoil or the material below it becomes susceptible to damage. Damage in the sense, maybe some kind of weathering may take place, and ultimately when weathering takes place, the material becomes loose and it starts moving down the slope under gravity. And then the amount of water, which has the major effect on slope stability, especially for loose sediments. So we can see that there are pore spaces in sand. If we take dry sand, we have these pore spaces, and if moist sand is there, these empty spaces have been taken up by by water, due to which it is moist. And when it is water saturated, that means these sand particles will float in the interstices water, and it will start moving down with the water. So that is the so its stability will depend upon the amount of water present in sand. So this, I'm just giving you an example of it. The causes of landslide. The first and foremost cause of landslide is the type of material. What kind of material is? If material is there, if solid material is there, which is not susceptible to landslide, then what is its structurally how stable it is, how it is, whether it is dipping along the slope or it is dipping across the slope, it will make it stable and unstable accordingly. So first of all, we have to see the material. Geologically, if it is weak material, it will be susceptible to landslide. Then erosion is second factor. Erosion takes place due to, of course, as we know, due to intense water in the region, rainwater in the region. The erosion will take place and it will bring down with it the loose material, due to which erosion will be there. And if erosion is there along the toe of a slope, then the slope will become unstable, and ultimately it will start moving down. So intense rainfall, I have already discussed. Human excavations, human interference with the natural slope of angle of repose. So this is happening when we are going in for various infrastructure development. Example, construction of road in hilly areas. So to construct road in hilly areas, we have to excavate along the slope. So when we excavate along the slope, we are interfering with the angle of repose. If the structure of the rock is such that it is not along the slope, so that those type of road will be stable than the ones where the rock is sloping to rock is dipping towards the slope, natural slope. So human excavation, I would refer it to as nowadays we say that, oh, this year we are having a lot of landslides as compared to the previous years. Every year the landslides are happening more and more happening. Landslides are happening. Why? I hope this is due to as we are trying to make more infrastructures, more roads, and more other such maybe houses particularly in hilly regions. Then we are interfering more with the natural slopes, hence without taking into consideration the right place for such an infrastructure. Right place, when I say right place, means the location, whether a particular infrastructure can be located in that zone or not. So the zone need to be investigated properly with respect to the type of material in that area, as well as the structure of rocks. So that's how we can make stable infrastructures. So human excavation is there. Then earthquake shaking, which again is beyond our control. But as a civil engineer, we can always make earthquake resistant structures. I think that is what Dr. Vinayak, one of my former colleague, must have discussed prior to my lecture here. And then another natural phenomena is volcanic eruption. where the volcanoes will erupt, and of course the melt material will come down and will destroy everything on its way. So these are some of the causes of landslides which are happening in nature. Now the geologists use a variety of classification scheme to describe causes of landslide. As I said in the beginning, that the landslide will depend upon the type of material in the area. First is type of material. Second is the structure present in the that material. What kind of structures are there? So, because of wide variety of causes, no single scheme has yet been developed that addresses or describe all type of landslide. So, different type of material will have different causes of landslides. So, that is material specific. Yeah, one thing is in common in all the cases is that everything, all the material comes down under the influence of gravity. That is common to all. But the causes will differ with respect to different type of material. Now, the external causes of
Professor Banstu, can you hear me?
yeah, I can hear you. Am I audible?
Yeah, please go ahead. I think there was some glitch.
Yeah. Okay. So the the geometrical change, as I discussed, I'll repeat it because there was some problem I think between. So we are changing the gradient. That means we are changing the angle of repose. So the natural angle of stability of the material. So first, by excavation we are increasing the gradient, and then secondly we are increasing the height also, because when we excavate we will excavate to a certain depth. That will give the height to that particular slope. And slope length, of course, the length of excavation, how much it is. For example, for a road, we may excavate 4 meter or 5 meter, depending upon the type of highway or road. So that's what is length. Then unloading or loading. Unloading can be natural, and it can also unloading and loading both can be natural and human induced. Natural in the sense, like after construction of road, we see that at certain places there are cracks which are appearing on the road surface. What are these cracks due to? So they may be due to loading due to plying of vehicle on the road, or it may be due to unloading, as there may be some toe cutting at the bottom of that particular slope. So that is unloading, and loading is then we move on the surface with maybe vehicle or load carried by a vehicle on the road. So this can also be human induced, both natural and human induced. Then shocks and vibrations. So shocks can be due to maybe the seismic shocks, and maybe vibration due to running of vehicles on the road or in the nearby, some construction activity going on or mining activity going on. So it may have the vibration induced causes for landslide or a rock fall. Internal reasons, causes are there. For example, progressive failure or internal response to unloading, etc. So expansion or swelling. So in case of, I think you all are well aware.
Sir, I think we are not able to see your presentation. I'm really sorry to pinpoint it again. Could you please,
wow.
yeah, share your screen? Thank you.
Oh. Where did it go wrong? Where did it go wrong? I think I was here. Then share screen. Can you see that now? Is it visible now? Okay. So I think this I had done, and then we were talking about the internal causes. We have expansion or swelling, as in case of the clay material. It swells upon absorption of water. Then fissuring also takes place. Then strain softening is another cause, or stress concentration is again due to internal response to loading and unloading. Then weathering. I hope you all are aware about this term, weathering, where we have physical property changes in the material taking place, and sometimes chemical changes also there. This type of changes, chemical changes, to large extent are usually seen in the limestone cut. Then seepage or erosion due to moving of water, groundwater or surface water. There is a removal of cementing material between grains of a rock or soil. So hence it is removed. Hence there may be the loosening of material. Hence erosion takes place. Then water regime change due to saturation of water. A lot of pressure is built up. If excess drawdown is there, due to saturation, there is a rise in water table, and excess pressure is there. If we go for excessive drawdown, then the material or the what do you call, the rock containing water will undergo compression. I think the best example of this result, we have Leaning Tower of Pisa. I hope you know about that. So that is what is change in water regime. The human cause is the excavation of slope or its toe that we have already discussed, and the loading of slope or its crest with the material from outside or due to dynamic action of vehicle, etc. Then drawdown of reservoir, deforestation, irrigation, mining, artificial vibration, and water leakage from utilities will also soften the material, and ultimately will lead to the sliding of material. Then we have because why I'm talking about this, ultimately I have to talk about mitigation, but as you know that we have to first know the causes. What would be the possible cause of a particular slope? Once we are able to pinpoint that this is the cause of this slope, then only we can go for right measures or right mitigation measures to control that landslide. So I'll take a little bit more time on that to understand the causes. The geomorphological and inventory map of slope movements and susceptibility map, which material are more susceptible to landslide, which areas are more susceptible to landslide, and which are less, where is the less probability of slide taking place. So if we go by material as well as the gradient, we can see that the gradient having less than 20-degree slope, in case of rock, we have low slip susceptibility, and where we have gradient more than 35-degree, we have high susceptibility rock falls. So likewise for rock landslides, less than 10-degree is low susceptibility, as whereas more than 35-degree is high susceptible. In between 10 to 35-degree is moderate or medium susceptibility. In case of soils, We have less than 10 degree, again, unless there is some little spread, this depending upon the material, we have low susceptibility, whereas more than 35 degree is a high susceptibility. Uh, in a nutshell, 35 degrees seems to be a natural angle of repose. That means the material, most of the material, they are stable at this particular angle. So depends, 30, 35 or 40 degree, depending upon the type of material. Then, yeah, so likewise, the zone can also be, classified. As we know that when we move across on the highways in hilly areas, we can see various signboards put up at various places that this zone is highly dangerous. That landslide prone zone is there. What makes that particular area landslide prone? Because the whole stretch of road is not landslide prone in most of the cases. At some places we may have a longer stretch susceptible to landslide, but usually this zone, they are well known for the danger of landslides and for the potential threat of life and property, because of the type of material in the area. Maybe the material is highly crushed and it is not hard enough to keep itself at its place. So these type of material where we have loosened rock masses, which in due course of time get spread or may get detached due to pore pressure developed due to water contents in that zone. And then we have high zone, moderately low, and unlikely. So unlikely is the zone where these slopes are not too high, and as well as the material is stable as compared to the material present in the high or severe to very high zones. So this is a map of our country where we see the highly affected areas are restricted to, or they are confined to, the hilly terrain. Highly, you can see Jammu Kashmir, Himachal Pradesh, and Uttarakhand. Then to Sikkim and Bengal, West Bengal. Then to northeastern states of Arunachal Pradesh and Nagaland, Manipur, and one more down there, Mizoram, I think. Yeah. So that means the problem of landslide is usually in the hilly region, where of course these may occur due to various reasons. So if we go through the history of landslides in India, I think this is just this is a data sharing, so you can have it on the internet also. You must have gone through it, but I'll just talk about some of the latest one which has occurred this year only. One is happened on 28th of July, that is in Chansha Nala in Lahaul Spiti, where 6 bridges were damaged, 13 people remain missing. And then again on 20th July in Chanir Tehsil of Chamba, 8 feared dead, 7 missing in flash flood triggered by heavy rain. And then on 14th of July in Bow Valley, I'll show you a picture of Bow Valley also, how it happened. I happened to visit that place after the landslide took place. So where 9 people were dead, and 4 were injured, and several houses were damaged. 300 road stretch was washed away. So I mean, it only maybe is confined to a smaller place, but when devastation or the accident occurs, so the whole structure, all houses, they are washed away. So this is again statistics. So if we go to the one which has created maximum loss, that was in 2005 in Baspa River in Sangla Valley, again where about 560 crore loss was there due to flash flood and slide. And one happened again in Satluj basin in 2005, where there was extensive damage caused to Nathpa Jakti project, about more than 600 crore worth damage was caused by the flash flood and landslide in the area. So this again, I'll not go through all this. Just a minute. We got a call from my director. Just a minute, please. हाँ जी सर, एक लेक्चर चल रहा था वेबिनार में ना, मैं करता हूँ आपको खत्म करके। आप यही है ना? मैं करता हूँ सर। थैंक यू। Yeah, sorry for the disturbance there. So you see this picture now here. What we see. So this on to the left is prior to the flash flood on 14th of July. So this is a Bo River. You can see running north-south, Bo River, and this is a smaller valley which is connecting to the main Bo River here. And you see that a lot of houses had cropped up, or they have been constructed along the this small rivulet, or we call it a nala. In a local vernacular language, we call it nala. And the houses, now most of the damage and most of the casualties were from these houses only, which were built very close to the nala here. Though the valley is not very big, you can see a very small valley. Maybe the extent is only up to 1.5 kilometers upstream from here. But due to heavy rain in this region, a lot of material, which of course, though there is no developmental activity in this region here, but due to weathering taking place in due over a period, so that becomes loose. As a result, the whole thing will come down under heavy rain. As a result, the blockage posed by these houses at the mouth or of this nala here, they were either washed away or they were buried under this debris. You can see. So this slushy material had, you can see a lot of people standing there after the rescue operation was going on in this region. So this is primarily due to the human interference. Had these houses been not there, so nothing would have happened. Even if this whole slushy material is coming down, it would have gone in its course. So it is stopped here just because you can see these houses which on your right are no more. They have been damaged, completely damaged. So the ones which are at a height, they are safe, and on the side they are safe. But the ones which were along the course, so they posed blockage to this material because it's coming with a high velocity. The volume is too high, so these houses could not resist that pressure. Hence, they were damaged, and we lost precious lives. So these are some of the precautionary measures which we must take care of before designing or before constructing, going for any type of construction along such places where we have these kind of rivulets or nalas there. Then another picture is that of Nigulseri. Received it from one of my friend. You can see, though I've got a video also, but I'm not posting it here. You can see the remnant of a truck that is teared apart by boulders and everything coming down. So I think some lives are also lost in this accident here too. This is what has happened today only. So had there been no vehicles along this road, nothing would have happened. Only thing is some material has come down, so we can remove the material and then start our activity once again. But maybe bad luck or whatever we may say, these people were trapped in this slide. So hence accident took place. Now, these whatever we have discussed so far was about the reason. What are the reason and what type of disasters do take place due to landslide? Now, how do we take the mitigation measures? What would be our mitigation strategies? So, just to start with the mitigation strategies, we have to look for first of all the whole area. For example, we talk about Himachal Pradesh. Whole area is hilly region, and taking upon various features. I think that I'll discuss here in this flow chart. You can see here the flow chart. We have to make to move it somewhere else. Yeah, to make the hazard map. Now, hazard map will consist of a zone, hazard zonation mapping. We call it hazard zonation mapping. That will have various types of inputs to hazard zoning maps. So this will consist of landslide reports, maps, field investigation text, etc., of every region in the for which we are. For example, we are making a hazard zonation map for a particular valley. For example, say Kullu Valley. So we would require these reports, how many landslides have occurred in the past years, and the map of the area, as well as the field investigation reports, and all other type of data that the primary input. Then the primary input will also include the remote sensing satellite data. That what is the change in the at different times in the area, and what is the crop pattern, what is the land use pattern of in the area, that also is required. Then image processing for mapping, landslide, and data verification can be done by site visiting, etc. And analysis of data source and landslide data will also have to be processed. So this whole process is called data collection. So once we have this data with us, we can go for a selection of landslide parameter and topology, where we'll have inventory maps and as well as the landslide database generation, which is spatial as well as attribute data with us. Of course, this can only be done with tools such as GIS. And then the what would be the area which are prone to landslide will have input. For example, the digital elevation map, slope map, aspect, soil map, geology map, drainage map, linear map, then road rainfall map, and other such map which are required. So that will have to have those as a base data with us, and then independent terrain variable generation, that is slope, aspect, soil, geology, drainage, and land use and land cover, etc., will have an input for the landslide hazard zonation. To this, we'll have to have a hazard and settlement map, because we'll have to take into consideration the settlements also. As I said in the beginning, then only we would be able to calculate the risk. We will able to assess the risk involved. So landslide zonation map, hazard zonation map, up till here we can make a landslide hazard zonation map. I'll show you at the end how a landslide hazard zonation map will look like. But if we have to have the risk assessment also, then we'll have to take into consideration the hazard and settlement maps as well. So that is what for what's wrong with this? Why is it moving? So that is what we call as hazard mapping. So this hazard mapping will be for the whole area, as I discussed, that they can be for a particular valley or for a whole region and for a whole country as well. But if we have to go for a large area, we'll have to have the data input for all such places. Then the The hazard mapping will locate areas prone to slope failures. This will permit to identify avoidance of areas of building settlements. So that means the precautionary measures we can put in place is like we can identify these areas uh, and not to plan any settlement or any infrastructure development in this zone, because that has fallen into a hazardous zone in a particular area. So these maps will serve as a tool for mitigation planning. So depending upon the degree of hazard assessment in the area, we'll have to go for a mitigation plan as well. So the main mitigation strategies will start from the land use practices. So areas which are covered by degraded natural vegetation in upper slopes, which are to be afforested with suitable species. The existing patches of natural vegetation and flood condition should be preserved. So that means when we are talking about the mitigation measures, we'll have to take care of the local species growing in the area. So as we venture higher up in the hills, making our fields for growing crops or maybe planting trees, that area, because we are interfering in that, that will again be vulnerable to slight. So first, we'll have to maintain the natural vegetation, do not degrade it, and never allow people to degrade it. Otherwise, then everything below that area is going to be affected. Maybe in due course of time, not they suddenly, maybe after 1 or 2 years, but it will take time and it will go on degrading if we are removing the natural vegetation in the area. So any developmental activity initiated in the area should be taken up only after detailed study of the region, and slope protection should be carried out if necessary, which usually we are not taking care of. We are just because we want to connect two places, so we have to have a road between these two places. I have come across so many places in Himachal Pradesh also where we have road connectivity, but we call it a bad road connectivity because the areas are not suitable for construction of road. Every time during every rainy season, the material goes down or subsidence takes place, hence poor connectivity of road. Maybe they are good weather connectivity only is in such regions. So in construction of roads, irrigation canal, etc., proper care is to be taken to avoid blockage of natural drainage. So of course, if we block the natural drainage, then what happened in Bo Valley, that is going to happen. The total avoidance of settlement is in the risk zone should be made mandatory. So as I discussed earlier, I'll just explain with the help of this picture here. So if we are taking this smaller zone into consideration, which is a zone of accumulation of water, rainwater in this area, you can see it is not too big an area. But as I told at the beginning, that they are due over a period of time, though no human intervention is also there, but due to the weathering effect, the upper material becomes loose, and due to heavy rain, it will come down, accumulating at the bottom here. Due to accumulation is taking place due to the obstruction of natural drainage. So this has happened due to this factor only. Had these houses been not there, so lesser damage would have occurred. So we should not allow any construction in the risk zone to take place. They relocate settlements and infrastructure that fall in the possible path of landslide. Now, you might have seen so many places where such accidents have occurred. Some disasters have occurred in the previous. Now people will come again and start rebuilding houses at that place only, because they know if this has happened, uh, once in the last 100 years, so next time it's going to happen another 100 years. So by the time we will also live, they'll live their full life. So in such areas, we should not allow the settlements to come up again, because they are going to be affected if they are blocking the natural passage of the drainage passage. No construction of building in areas beyond a certain degree of slope. Yeah, as I said, we should not disturb the angle of repose also, because if we disturb the angle of repose, we must take precautionary measures, or we must take help of engineers to stabilize such slopes by various by constructing or by taking various measures. So you can see this sketch here. Avoid building or near on or near steep, high risk slope, and avoid modification that increase the risk of landslide. Because in hilly terrain, usually what we see in our Capitol Hill, or we see in Dharamshala region also, where we have slopes. If we construct our house here by making a retaining wall or giving some stabilization to this slope, because the area above this particular area will belong to some other person, so he'll also excavate and dump some of the material over this stabilized zone, and in due course this retaining wall will also give way and posing danger to the houses which are constructed below. And this is this makes a cascading effect along a slope. So we should first of all check whether what is the slope or bedding dip of the rocks in the area, in this zone. So if it is towards the slope, that means this is most vulnerable zone for landslide. We cannot just stabilize such kind of slope, because the water will seep through these bedding planes, hence the whole rock mass will start moving down, damaging the structure, or we'll have to spend or anchor it properly by some engineered structures to stabilize the slope. So that is what. Then retaining wall can be built to stop land from slipping, but as I told you, the building of retaining walls is for the material which is at its place. But if it is overloaded from material dumped from outside, then that is not going to happen again. So it is constructed to prevent smaller sized and secondary landslides that often occur along the toe portion of a large landslide. We cannot stop the large landslide merely by constructing these retaining wall. Then before constructing such structures such as retaining wall, proper drainage control work should be put in place, because the rainwater, which acts as a triggering factor for landslide to take place, we should treat the area so that minimum water seeps down the down the slope. So we have to have a proper drainage constructed at top, so that the water can be diverted from the slope. So the surface drainage control works are implemented to control the movement of landslide, accompanied by infiltration or rainwater and spring flows. So this kind of engineered structure can be constructed to divert the flow of water down the slope, so that the minimum infiltration of water takes place down the slope. So we can have make it by installing drain system to reduce the amount of water in a slope can reduce the risk of landslide. So you can see here surface drainage they can be constructed and water can be diverted from seeping below. So we have this system of fixed pond drainage, which is on an unstable slope. I've taken the picture from a book, so it is from Italy. So you can see excavation of a ditch or drainage is along a perimeter drainage ditch to stabilize the landslide. So perimeter means we can construct it along the slope, along the boundary of the slope. So we have a perimeter drainage to stabilize the slope so that we can divert the water. Then engineered structures with strong foundation can withstand or take the ground movement forces. So that will have to be constructed by taking into consideration the force which the rock mass or the soil is going to exert on these such kind of engineered structures. Then underground installations, pipe, cables should be made flexible to move in order to withstand forces caused by the landslide. Then increasing vegetation cover is the cheapest and most effective way of arresting landslide. This helps to bind the top layer of the soil with layers below while preventing excessive runoff and soil erosion. So this we've been studying right from our childhood, maybe school days, that the roots, they bind the top surface, top soil, hence doesn't allow the surface runoff, hence there are minimum chances of flash flood in the region. Then of course the precautionary measure is to ensure the structure. So at least the individuals, they can be this can help them financially, even if the structures are damaged due to these type of hazards. For new construction, it should include standards for selection of the site as well as construction techniques. So yeah, depending upon the zone, so a proper code should be utilized for designing these structures. Then we can also go in for a flattening of the slope. The slope at the point of failure may be stabilized by the slope to a flatter angle on the basis of proper geotechnical investigations done either by grading the slope from bottom to top with benching, whichever is necessary, or cut in or make a cut in the upper hills. So we can go in for benching so that the material is not moving down under the influence of gravity. So one such example is in this sketch here. You can see we have a road constructed here because it is unstable, because the rocks are dipping in the direction of the slope. So this will move down. What measures we can take? We can remove the whole hill here so that nothing moves down, or we can construct the road on other side of the hill where the rocks will be dipping into the hill, making this type of structure, that the road here, more stable as compared to done on the right side of this hill. So it can be done. So that is the best method of rerouting this type of infrastructures. I think we do take care about these while construction of roads and bridges, etc. That is important because the natural slope, the natural dip of rocks will help us in a greater way in stabilizing these slopes. Otherwise, it will take a lot of efforts to stabilize such slopes if they are not favorable with this kind of structures. Then the stitching of the debris covered to the rock. So what we can also do is we can go in for by micro piles, for example timber piles, to stitch the topsoil with the debris or with the base rock, so that it doesn't move down. So it doesn't go down under the influence of water or gravity. Then the construction retaining wall, we have already talked about, built at the bottom of a slope, but the base of the wall should be properly anchored into the rock. So that's what is not happening. I think you all will agree with me. What we are simply doing, if we have a landslide in an area, what we do mostly are people will go there and make a wall over it. Just below the road, they'll make another wall, and this wall also goes down because we are loading that area that is already sliding. We are again loading it without realizing that this particular wall should be anchored to the stable, strata at the bottom of it. So without knowing it, we will go on construction retaining walls, year by year, hence wasting a lot of public money into it. And these, if we have big landslides, they cannot be controlled by retaining walls. Only thing, as I told you, that we can only control the slide along the roadside, where we are excavating or disturbing the angle of repose. Only small amount of material can be retained. Otherwise, a large landslide cannot be retained by such retaining walls. So better we should look for the suitable structure in the rock, their orientation, and possible routes to construct road or big structure. Then we can also go for grouting, effective method of improving the shear strength and decreasing the permeability of coarse-grained soil. This can be suitable for filling void in the rock mass, or cement grouts are injected under pressure to close the void so that there is no movement of water, or the pressure is due to poor pressure is not developed due to the water there. So we can also go in for grouting. Another very important and the latest one is geotextile. So geotextile wrapped filler drains are inserted into the slope extending beyond the estimated slip surface. So they are connected to the crib wall at the base, which is made of crushed rock to provide drainage of water from the transverse drains. So this geotextile will help us in retaining the material along the slope and let the the water seep through it, which is of course filled at the base of such slopes. So you can see here a diagram of measures taken to retain the landslide on a alluvial silty clay soil over a subsystem of mud and sandstone. So these are you can see the dashed portion is these are the rocks, which are of course will help in anchoring the superficial structures which are constructed to stabilize the slope. Various types of structures, you can see from Gabion wall to anchored wall, and then intermediate wall, or the colluvium at the top, and sometimes we can also regrade the slope so that it becomes less vulnerable to landslide. So as I told earlier, if we have to make a retaining wall, that needs to be grouted, that needs to be anchored to some of the natural structures or natural strata along the slope, so that it doesn't go down. Otherwise, what will happen? We'll go on increasing load on the slope or lose material on the slope, which ultimately will be vulnerable to slide year by year, and particularly during rainy seasons. And I'll show you some pictures where we have these pictures are taken as a protection for rock fall. So in many areas, rock faces are stitched with massive steel bolts to keep material from being rolled down due to weathering of contact surface. Alternately, surface can be covered with strong mesh or boulder catching nets can be used. So if such boulder, you can see here, it is put at place only, but if it comes rolling down from top, it can damage the net also and pierce through it and move down. But if it is stitched to its place, so before moving only, if it can be retained there, so it will be a stable zone. So if we happen to visit, the developed countries, they have such type of uh, engineered structures built along the slope to contain or to avoid accidents. So you can see here also we have a horizontal dynamic barrier there, so that if at all rock falls on along the slope, the vehicles which are crossing this tunnel, they are protected. Then we have again a large net that is anchored to the rock, so to making it to stabilizing it. Then we have static barriers made of posts and meshes for protection against rockfall. So they are again engineered structures where they can be utilized to stop the falling of material from along the slope. And then these are dynamic barriers to retain rockfall. So they'll absorb some of the forces of these moving stones or rock along the slope, so that the accident doesn't take place. See here already affected net here. You can see the material has already pushed it downward, but maybe a lot more lives can be saved due to such structures. So then precautionary measures, as I told you earlier, that first of all, we should look for a place or a region where there is very less occurrence of such type of disaster. So the hazard from landslide can be reduced by avoiding construction on steep slope and existing landslide, or by stabilizing the slopes. Also, not to construct along the natural course of water flow or nala for that matter. And then stability increases when groundwater is prevented from rising in the landslide mass. So covering this is a quite a common feature along the hilly areas. So during rainy season, the areas under construction, they'll cover it with some synthetic material to stop the the water from moving underground. So it can be covered with an impermeable membrane or plastic material. Then directing surface water away from the landslide, then draining groundwater away from landslide, minimizing surface irrigation. Then slope stability is also increased when a retaining structure or the weight of the soil or rock berm are placed at the toe of the landslide, or when mass is removed from the top of the slope. Either we offload the material from top, or we can also stabilize it by constructing engineered structure at the toe. But we are doing other way around. We keep on loading the slope which is already going down by constructing walls on along the slope. That is a common feature in our areas. That's what our engineers are mostly doing. Then we can also go for artificial tunnel or rock shelter for protection from rock fall on a road in a so there is in a region. So if such region are vulnerable to rock fall, so they can go in for artificial tunnel, so that if anything if from some rock fall is there, so the people commuting on the road, they are not affected, or to prevent the accident. I think that was all from me so far as the mitigation measures and the landslide, the types of landslide that we know so far. Uh, so I think we are open
Yes,
to
sir.
any
Yeah.
question there.
Thank you very much, sir, for lecture on a topic that is very much needed or need of the hour these days. I just few minutes back saw that Kinnaur mishappening, and that is definitely highlighting the need for these kind of remedial measures to be installed on these locations. So with these words, my request to all the participants to ask any question or query by raising their hand, and then we can unmute them. Yeah, I think Mr. Sridhara would like to ask one question. So
Yes,
I have unmuted it. Go ahead, sir. Please ask your question.
Yes, sir. Thank you, sir. Thank you, sir. Thank you for the very important information given by you, sir. Sir, my question is, am I audible, sir?
Yes, go on.
Yeah, sir. My question is, what is, from past 2-3 days, just I thought of asking this question. What is the influence of fault planes on this phenomena of landsliding?
Yeah, as I discussed when I was talking about the slope, slope or dip of stratas. Likewise, if we are running, if we have a presence of fault in a region, fault is also a weak plane, because the rocks have moved along that surface. So that whenever this fault plane, this fault plane is lubricated with water, and water percolates down this fault, ultimately the water will be collected down the slope at some place, which will again increase the pore pressure, hence leading to landslide. So what we can, the best mitigation measure is to seal this region along which we have made structure, maybe for example a building or we have constructed a road. So in that zone we can seal the exposed portion of the fault with some, maybe by grouting or by some other measures that can be done. And secondly, such regions are more vulnerable to landslide due to seismic shocks. So because when seismic waves travel, so these portion where we have these active faults, they are also vulnerable. So yeah, of course, along faults that needs to be treated to avoid landslide. Again, depending upon the type of rocks in that area and the slope of or the dip of the fault plane. Yeah, I hope I've answered that.
Absolutely, sir. I think you have very well answered the query. So any other question from anyone? I think, sir, we just had one question, and
okay.
Yes, but sir, I was wondering, like, these kind of rock slides, or when these rock chunks come down. So what is your suggestion? This I think this artificial tunnel, the problem with it is very, very costly affair, very, very costly affair. And what about rock shed? What's your comment about rock shed? Do you think that it's also a feasible solution, or?
They have constructed rock sheds also. At places I happened to visit once. Was invited. I went to attend an international conference in Switzerland, and where we saw that they have bypassed a nala itself by constructing such sheds. Because now underground we have a road, and they have constructed a shed where water will flow from, if at all there is debris flow. So they construct this kind of a shed.
Right, but yes, sir. But we still don't see these kind of solutions in India.
Yeah, of course. We've been they are very well in these literatures, but as I told you, we hardly take it to practice.
Right.
Only practice we have that we go on constructing retaining walls along the slope, making it more
Right.
vulnerable to landslide, than actually mitigating it.
Right, sir. I think then there comes the role of experts like you. So your role is very much crucial for state and as well as for the nation.
Yeah,
So
we'll be happy to
I think we can
contribute that way.
this.
Why not?
Yeah, right. And so also I look forward for your guidance and collaboration. Being a young department and you being in a very prestigious institute of the country, so definitely next time it would be a pleasure to host you in person in the beautiful hills of Shimla.
Yeah, sure. We'll. I'll be. It's my pleasure.
Right. So with these words, I again thank you, Professor R.S. Banstu, for joining us for this lecture. Thank you, sir. Thank you very much.
Thank you for providing me this platform to interact with participants. Thank you so much.
Yeah. Thank you, sir. And dear participants, with these words, I think we can conclude today's session. And for tomorrow, we have 3 speakers. The first speaker is a wonderful human being, Ramnik Bansal, a spiritual teacher, and he is going to speak over the role of spirituality in academia. And then we have Dr. Ashutosh Kumar from IIT Mandi and Dr. Tejas Kumar Garela from University of Nottingham, UK. Mr. Garela is also a very popular researcher, a young researcher who is a pass-out from University of Cambridge. So I look forward for tomorrow's lectures to interact again again with you all. With these words, I conclude today's sessions. If you have any comment, suggestions, you please put them on the WhatsApp group. And I have already shared the feedback link with everyone. I will also upload it or put it in the WhatsApp group. Thank you. I hope you had a wonderful day with us through this online mode, but it would have been great to host you in person. Thank you very much to all of you. See you tomorrow at 10:30 a.m. The first lecture is something that we would all be loving to attend because of spirituality touch to academia.